Chapter 1. Section, The Shores of the Cosmic Ocean. In the beginning, before time held dominion and the stars were merely whispers in the dark, there existed primordial beings known as the sorcerers. These luminaries, called the sorcerer of fatal laughter, the sorcerer of night, unkempt, and the black sorcerer, emerged from the creative void, ethereal entities birthed by the Creator's longing to bring forth consciousness. They were not mere forms, they were entities of intelligence and unparalleled understanding who followed the vibrations of existence itself, comprehending all that lay before them in a breathtaking clarity. With vigilant eyes, they gazed upon the vibrant tapestry of life, the pulsating rhythm of the flora and fauna, the ever-turning sky filled with stars and mysteries, and the rounded face of the earth itself. They slipped seamlessly between dimensions, their awareness a river coursing through the cosmos. Yet, in this boundless knowing, the Creator felt a tremor of uncertainty. He posed a question, echoing through the void, these beings know all. What shall we do with them now? Let their vision grow limited, confined to what is near, let them see only fragments of our wondrous creation. Are they simple creatures by nature, not fashioned for divinity? The existential query lingered, prompting reflection that reverberates through time. Are we not all, in some way, given the gift of understanding yet rendered fragile in it? Our quest for knowledge, while expansive, requires guidance. Wisdom is not simply the sum of all facts, it prompts us to question deeper truths about our existence, our purpose, much like those echoes found in ancient texts, such as the haunting lines of the Book of Job, "Have you comprehended the expanse of the earth? Where is the way to the dwelling of light, and where is the place of darkness?" As humanity unfolds through generations, we stand on a solitary isle within an endless ocean of uncertainty, a notion captured eloquently by T.H. Huxley. The known is finite, while the unknown stretches infinitely before us, teasing our senses with its mysteries. This dynamic between the known and the unknown has compelling implications, as discoveries illuminate our path, even if only incrementally, reclaiming a small patch of territory from the boundless unknown. The cosmos is a grand stage set with magnificent wonders, encompassing all that is, was, or ever could be. Each contemplation of the cosmos stirs something primal within us, it ignites a feeling of reverence and vulnerability. We stand at the threshold of the great mysteries, teasing out the cosmic silence with whispers of curiosity. The size and age of the universe stretch beyond monuments of time, concealing our humble earthly abode somewhere adrift between vastness and eternity. In this perspective, many of our petty human concerns seem a mere flicker against the grandeur of existence. Yet our species, brimming with curiosity and fortitude, continues to unveil astonishing revelations, unraveling deep questions posed by existence. These revelations remind us that understanding brings joy, nourishment for the spirit, and is vital for our survival. Our future, indeed, hinges upon our quest for cosmic comprehension as we float like motes of dust in the early morning light, reflecting the depth of our inquiries. Each exploration necessitates a delicate balance of skepticism tempered with boundless imagination. While imagination may beckon us to innovate with dreams untethered to reality, skepticism grounds us, sharpening our discernment. Within the richness of the cosmos lie elegant truths, intricate interconnections, and mechanisms that inspire awe. The surface of the earth stands as an inviting shore, a thin line dividing the familiar from the unfamiliar. We have merely dampened our feet, peering curiously into the cosmic expanse, longing for deeper immersion. A hum of nostalgia surfaces, beckoning our spirits toward the unknown, toward the origin from which we came, and to which we yearn to return. Such aspirations, it seems, echo thirstily from the depths of our souls, not as irreverent pursuits but as echoes of our inherently divine nature, challenging gods and stars alike. Given the titanic dimensions of the cosmos, employing earthly measures like meters or miles feels trivial. Instead, we adopt the speed of light as our cosmic yardstick. In the blink of an eye, light traverses 186,000 miles, traveling near 300,000 kilometers at a breakneck pace, encircling the Earth 7 times within a heartbeat. In just 8 minutes, light bridges the gap between the Sun and our planet, reminding us that distance transcends time. A year's worth of light traveling through the void spans nearly 10 trillion kilometers, a breathtaking distance measured by light years, a term that captures enormity without the confines of temporal existence. Our Earth, this charming, vibrant planet, is but one speck amid countless celestial bodies. It is extraordinarily unique, yet perhaps unremarkable in the vast scheme of the cosmos. No celestial body can be categorized as typical, since the universe consists primarily of the cold, immersive void, the boundless dark that can overwhelm, yet also nurture wonder. In this grand narrative, our quest continues, a journey to understand the chaos and order of existence, to confront our place amongst the cosmic tides, and to reach beyond the shores of our earthly confines into the echoing vastness of the universe that awaits. And perhaps, in those distant realms, we'll find not just answers, but a piece of ourselves, the very essence from which we emerged in the first place. As we wander along this stretching shoreline of existence, we must remain ever curious, ever questioning, for every wave that rushes toward us carries the promise of new discovery and insight into the enigmatic nature of the cosmos itself. Intergalactic Chronicles, the Dance Among the Stars. In the expanse of intergalactic space, a realm both bizarre and desolate, one could easily lose sight of the beauty hidden within the void. Planets, stars, and galaxies emerge as delicate petals in an unfathomable wilderness, each twinkling entity achingly rare and undeniably lovely. If we were to be cast randomly into this vast cosmic ocean, the probability of finding ourselves on or near a planet would be staggeringly minuscule, a mere 1 in a billion trillion, 10 to the power of 33. In the lexicon of daily life, those odds evoke admiration. It serves as a solemn reminder that worlds are treasures, each one as unique as a snowflake amidst the cosmic snowstorm. Standing at the brink of the universe, gazing from an intergalactic vantage point, we would observe a tendril of lights shimmering across the dark canvas, like frothy waves kissing the shore. Galaxies, innumerable in their grace, float through the ether. Some drift alone, solitary in their wanderlust, while others cluster together, a close-knit family navigating the infinite dark. This is the majesty of the cosmos, unfurling in grandeur that could hardly be conceived, with our view stretching 8 billion light-years from Earth, halfway to the edge of the known universe. A galaxy is a concoction of swirling gas and dust, interspersed with billions upon billions of stars, each radiating a unique light, each a potential sun to distant life forms. Within these splendid edifices, there lies the promise of worlds, perhaps thriving with vibrant ecosystems, teeming with intricate forms of life or even civilizations that traverse the stars. When viewed from afar, a galaxy resembles a collection of exquisite artifacts, seashells or coral, crafted by the hands of nature over eons in this cosmic sea. With over 100 billion galaxies, each boasting an average of 100 billion stars, our universe teems with potential. In the totality of this vastness, the conjectures of planets rival those of stars, presenting us with a staggering figure of 10 billion trillion. In the face of such overwhelming abundance, how can we rationalize that only one ordinary star, our beloved Sun, has a companion fertile with life? What fortuitous twist of fate has allowed us to find ourselves within this niche? It seems far more plausible that the cosmos is buzzing with life, yet our grasp on certainty remains elusive. We are just embarking on our explorative journey, already dwarfed by the scale of the universe. From this unimaginable distance, even locating our Milky Way galaxy feels like searching for a needle in a cosmic haystack. Earth appears as a mere glint, a tiny speck of rock and metal, reflecting sunlight, utterly lost to the vastness. However, our voyage leads us closer to a section of space humbly referred to as the local group of galaxies. This unassuming cluster spans several million light-years and is home to roughly 20 galaxies. Among them is M31, the Andromeda Galaxy, visible from Earth as a glowing pinwheel of stars, gas, and dust. Like a matriarch watching over her children, M31 is flanked by two small satellites, elliptical dwarf galaxies that orbit her, bound by gravity and the unchanging laws of physics that weave through the fabric of existence. Nature's laws resonate universally, providing a singular framework that governs all matter across the cosmos. Here, we find ourselves 2 million light-years from our home. Beyond Andromeda lies our own Milky Way, a colossal spiral spinning leisurely over 250 million years. Approaching 40,000 light-years from our place of origin, we begin to drift toward the galaxy's enormous center. Yet, finding Earth, a mere blue dot nestled among innumerable stars, requires not just our sight but a deliberate course redirecting to the galaxy's outskirts, toward an obscure location at the edge of a distant spiral arm. As we navigate through the cosmic vastness, our senses are stirred by the breathtaking spectacle, a dynamic symphony of stars streaming by, each a luminous beacon against the darkness. Some stars appear as fragile as soap bubbles, while others possess a size capable of encompassing tens of thousands of suns or billions of Earths. The heterogeneity continues, where solitary stars mirror our own sun, while many belong to tandem systems, two celestial companions spiraling together in the void. Here, in the celestial theater, a continuum exists, from triple systems to loose clusters, each configuration performing its own age-old dance among the firmament. And so, as we traverse this extraordinary domain, the essence of the cosmos enshrines an intricate tapestry of existence, reminding us of our own fragility. We are but wanderers in this immense expanse, attuned to the whispers of the stars. The deeper we delve, the more we become enraptured not just by the wonders of creation, but also by the tantalizing mystery of life among the stars, a quest forever imprinted in the heart of humanity as we embrace our place in this grand cosmic journey. The shores of the cosmic ocean. In the vast expanse of intergalactic space, a place so strange and desolate that it evokes both wonder and trepidation, the universe stretches far beyond our wildest imaginations. Here, in this vast cosmic ocean, the brilliance of countless stars twinkles like diamonds scattered across a velvet sky. The sheer scale of our universe renders even the grandest earthbound marvels trivial. An infinitesimal cycle of life dances within the shadows cast by the resplendent glow of globular clusters, where millions of suns converge in spectacular harmony. Amidst this breathtaking panorama, we encounter various kinds of stars, each a universe unto itself. Some double stars cling so closely they appear to touch, their fiery souls intertwined like lovers under a blanket of night. Others, like the supernovae, blinding beacons in the cosmos, flare with an intensity that rivals their entire galaxies. These celestial bodies occupy a space as isolated as the distance between Jupiter and our Sun, where time and light intertwine in a delicate ballet. Yet, as bright as some stars illuminate the void, others conceal their presence entirely. Black holes, shrouded in mystical darkness, elude detection even from a mere kilometers away. The stars themselves hold a myriad of stories, some shining with a steady glow, while others flicker with uncertainty, caught in the throes of chaotic dance. There are those that rotate with an elegance befitting royalty, and those that spin with fervor so intense they morph into flattened shapes, distorting cosmic identifiers of beauty. In hues ranging from blue to red, these stellar giants signify their ages: blue stars, hot and young; yellow stars, middle-aged and conventional; red stars, winding down their life cycles; and tiny white or black stars, on the brink of their final breath. Within our own Milky Way galaxy resides a staggering 400 billion stars, each one moving with an intricate elegance, a spontaneous symphony guiding the cosmic dance of existence. When we consider the vastness that surrounds each star, we must acknowledge each star system as its own isolated island in a sea of darkness, quarantined from its nearest neighbors by light-years of empty space. One can't help but imagine civilizations sprouting on distant worlds, beings evolving through eons into glimpses of knowledge amid their quiet, spinning orbs. In their limited scopes, they might initially believe their unique planets and scant suns constellations proclaiming the entirety of existence. But just as we have embarked on our own journey of cosmic awareness, so too might they gradually awaken to the vast beauty and interconnectedness of the cosmos. Some stars, with their orbiting companions, may cradle lifeless rocky worlds, countless in number and frozen in embryonic stages of creation. In that cold seclusion, planetary systems may lie in wait, reminiscent of our own, at the periphery, swirling giants adorned with spectacular rings of gas and icy moons, while inside, small yet vibrant planets harboring lush environments or perhaps barren strays, yearning for energy from their distant sun. On some of them, intelligent life may have arisen, orchestrating magnificent transformations of their planetary surfaces. Perhaps they engage in monumental engineering feats, reshaping their worlds as they chase knowledge and discovery. These celestial neighbors, our distant brothers and sisters, could harbor similarities profound yet unfathomable. What are their forms? Their intricate biochemistries? Could they share our history, wrangle with politics, nurture sciences, and express art? As we ponder this possibility, let us not forget our own solar system, a mere light-year from the cradle of humanity. This familiar territory surrounds our Sun, at its very heart, a stellar inferno of hydrogen and helium engaged in nuclear fusion, inundating its planetary companions with radiant light. Outside our immediate world lies a spherical swarm of icy cometary nuclei, giant snowballs containing organic molecules, poised to be flung into inner space by the gentle tug of passing stars. These wanderers bring a sense of imminent excitement as they arc through the solar system, trailing veils of animated dust, ignited by their fateful encounter with our blazing sun. Approaching the planets, we marvel at their varied forms, the giant gaseous realms, Neptune, Uranus, Saturn, and the masterful giant, Jupiter, each keeping company with their own families of icy moons. Within the dynamic interplay of warm and cold bodies, our eyes are drawn to Mars, the red planet, home to remarkable features like towering volcanoes, sprawling rift valleys, and tempestuous sandstorms that may have once supported simple life forms. As we paint this expansive canvas, we see one remarkable truth: all planets are tethered in harmonious bouts of motion, circling the life-giving sun. At the end of our introspective journey through the infinite reaches, we return to our small, fragile blue-white orb, the Earth. It is, in essence, a jewel adrift in a colossal cosmic ocean, one among a multitude of worlds. In the grand scale of the universe, it may be but a fleeting speck, yet to us, it is home, our sanctuary and foundation. It is here, on this blue planet, our species has prospered, matured, and ignited an insatiable curiosity to understand our origins and what lies beyond. Each day, amid a blend of hope and uncertainty, we strive to define our existence and navigate our destiny within the greater cosmos. As we look up into the expansive night sky, with all its mysteries and marvels, we are reminded of our origin, our connectedness, and our eternal quest for understanding, a journey that has just begun amid the shores of the cosmic ocean. In the vastness of intergalactic space, a realm that stretches beyond the realms of human imagination exists, an expanse so unfathomable and desolate that its solitude dwarfs the grandeur of countless celestial bodies. Imagine the countless planets and stars scattered across this cosmic void, each one a mere speck compared to magnificent globular clusters, each resplendent with a million suns igniting the darkness with their brilliance. Yet, amidst all this cosmic mystery, one small planet stands out from the infinite void, our home, Earth. Welcome to Earth, a unique oasis in the vast, unyielding desert of the universe. It boasts resplendent blue nitrogen skies that stretch endlessly overhead, oceans teeming with life, lush green forests whispering ancient secrets, and soft meadows dancing under the gentle caress of the wind. This planet, in its delicate balance of ecosystems, is not just a mere geographical location, it is a vibrant cradle of life, exceptionally rich, remarkably intricate, and undeniably beautiful. In the grand cosmic perspective, Earth is a rare gem. As I mentioned, it is poignantly beautiful, but it is also, for a moment in the history of the cosmos, truly unique. After an extended journey through the annals of space and time, Earth remains the sole world where the very atoms that once danced together in the aftermath of the Big Bang have somehow forged life and awareness. It is tempting to suspect that this vibrant existence is replicated across the cosmos. Many such worlds must linger in the shadows of distant stars, waiting to be discovered. Yet, as civilizations grow, our quest for knowledge begins right here on Earth, informed by the collective wisdom garnered through the sweat, tears, and triumphs of humanity over the course of 1,000,000 years. We are fortunate to live among brilliant souls, individuals passionately driven by curiosity, in an epoch when the pursuit of knowledge is celebrated and revered as one of the highest endeavors. As we delve deeper into our past, we find ourselves transported to the ancient Near East, to a city called Alexandria, the hub of knowledge and culture in the 3rd century BC. It was within this vibrant metropolis that a remarkable soul named Eratosthenes unearthed an essential truth about our Earth. Despite the jibes of envious contemporaries who labeled him beta, suggesting he was second best in all things, Eratosthenes was, in reality, the epitome of brilliance in almost every field he touched. He was an intellectual polymath, an astronomer, historian, geographer, philosopher, poet, theater critic, and mathematician. His prolific writings spanned subjects from astronomy to philosophy, creating a treasure trove of knowledge for generations to come. Eratosthenes, serving as the director of the legendary Library of Alexandria, one day came upon a curious discovery while perusing a papyrus scroll. This piece of text spoke of an astonishing phenomenon occurring at noon in Syene, a far-off frontier town near the first cataract of the Nile. It noted that on the summer solstice, vertical sticks cast no shadows in Syene, but the moment was fleeting. As the sun rose higher, reflections could shimmer in the clear water at the bottom of deep wells, a testament that indeed the sun was directly overhead. At first glance, one might dismiss such an observation as trivial. What of shadows, reflections, or the sun's position? How could these commonplace elements hold any significance? Yet, Eratosthenes was not merely a man of numbers or theory. His inquisitive spirit drove him to experiment. He, too, observed the shadows cast by vertical sticks in Alexandria during the same midday hour on June 21st. And to his intrigue, they cast shadows, a clear indication that something greater lay beyond the obvious. Eratosthenes pondered the implications of his findings. How was it possible that at the same moment, a stick in Syene cast no shadow while another stick in Alexandria, located further north, bore a significant shadow? Imagine a map of ancient Egypt in your mind, 2 vertical sticks of equal height, one planted in Alexandria and the other in Syene. When the sun was directly overhead in Syene, one could easily assume the same for Alexandria if Earth were flat. However, if those 2 sticks cast shadows of equal length, logic would still govern this perception on a flat surface. After all, the sun's rays would strike each at the same angle. But how could Eratosthenes reconcile the simultaneous absence of shadows in Syene and the presence of distinctly drawn shadows in Alexandria? He realized that the only plausible explanation was that the Earth curved beneath them. The varying lengths of shadows revealed its spherical nature, showcasing that as the sun's rays hit surfaces at different angles, they must necessarily create differing shadow lengths. The magnificent distance separating Alexandria from Syene accounted for the discrepancies Eratosthenes observed, a scientific deduction firmly rooted in the majesty of observation and reason. Thus, through the curious mind of Eratosthenes, humanity was awakened to the curvature of its own world, a small yet profound recognition in the grand scheme of existence among the universe's infinite dark. Indeed, the universe is vast and filled with mystery, and our home, the planet Earth, with its blue nitrogen skies and oceans of liquid water, has become a pivotal point on our journey through the cosmic ocean, a journey we must undertake with ever-deepening understanding and insatiable curiosity. In the vast canvas of the cosmos, where a few dozen stars twinkle among great globular clusters teeming with the light of a million suns, lies a small, vivid planet, Earth. With its azure skies graced by plenty of nitrogen, and its surface adorned with deep, life-giving oceans of liquid water, Earth emerges as a cradle for adventure and contemplation. Visualize this planet, where the angle of radius sticks, extending deep into the core, would intersect at a notably mystical 7 degrees. This angle, just 1/50th of the complete 360 degrees that represent Earth's majestic circumference, was once a mystery waiting to be unraveled. In antiquity, one brilliant mind named Eratosthenes began to chart the intricate fabric of our world. With clarity of thought and an indomitable spirit, he sought to unravel the dimensions of our globe. He knew, Through careful observation and hiring a guide who painstakingly paced out the distance between the cities of Alexandria and Syene, that this journey measured approximately 800 kilometers or 500 miles. In an audacious leap of mathematical insight, he multiplied this distance by 50, concluding that the circumference of the Earth was about 40,000 kilometers, or 25,000 miles, a striking revelation for a man living over 2,200 years ago. Armed with nothing more than common tools, sticks for measuring shadows, keen eyes to observe the heavens, feet to traverse the land, and an inquisitive mind, Eratosthenes achieved a remarkable feat with an error margin of only a few percent in his calculations. He stood as the first to accurately assess the size of our planet, forever changing the course of human exploration and understanding. During Eratosthenes' time, the Mediterranean world was a maritime hub, renowned for its seafaring exploits. Alexandria, standing as the greatest seaport of its age, served as a launching point for adventurous souls, eager to chart unknown waters. The acknowledgement of Earth's spherical shape naturally ignited a flame of ambition in the hearts of explorers. Would they not yearn to sail toward undiscovered lands or attempt to encircle the globe, driven by the thrill of the unknown? Though centuries prior, a courageous fleet of Phoenician sailors, serving under the Egyptian pharaoh Necho, had managed to sail around the continent of Africa, an audacious endeavor that took 3 long years, mirroring the flight time of a modern spacecraft traveling from Earth to Saturn. Still, it was merely a prologue to the grand voyages that followed Eratosthenes' revelations. In the wake of his discovery, daring sailors embarked on treacherous journeys, navigating with ships no larger than fishing boats and equipped with basic instruments. They relied on the age-old methods of dead reckoning and the positions of familiar constellations, relying heavily on the stars that had guided so many before them. Amidst the vast expanses of an uncharted ocean, these celestial patterns became both a beacon of hope and a steadying presence for those brave enough to venture forth. Yet, while some sailed valiantly, no one would truly succeed in circumnavigating the Earth until the time of Magellan. One can only imagine the tales of heroism and adversity told as seasoned sailors and navigators navigated by the mathematical insights of Eratosthenes, placing their fates firmly in the hands of theory grounded in observation. In that ancient world, globes depicting the Earth emerged, offering perspectives that captured their understanding of land and sea. These globe-shaped models were fairly accurate near the well-trodden coasts of the Mediterranean. However, the further one sailed from their shores, the more imprecise these maps became. Similarly, our current knowledge of the cosmos, though rich and profound, retains the same flaw. It too becomes increasingly uncertain as we venture into the unknown reaches of space. The first-century geographer Strabo alluded to the challenges faced by explorers of his time. He noted that those who returned from attempts to circumnavigate Earth often claimed not to have been obstructed by land masses, but rather by their lack of courage and the scarcity of supplies. Eratosthenes himself spoke of the vast Atlantic Ocean as a barrier that, if absent, could easily permit traversal by sea from Iberia to India, hinting at the potential for undiscovered worlds teeming with life beyond their own. This spirit of exploration and thirst for knowledge was palpable. Even then, humans began to stretch their boundaries, grappling with the notion that other habitable worlds might exist, perhaps populated by beings entirely different from themselves. Thus began humanity's long-standing journey to seek out not only the physical terrains of our planet but to challenge the very fabric of understanding, extending a hand to the possibility of other worlds beyond. Welcome to the planet Earth, a microcosm of extraordinary adventures under blue skies and vast oceans. Where curiosity meets courage, and where every journey begins with the imagination wielding simple sticks. The legacy of Eratosthenes and the countless explorers that followed reminds us that our quest for knowledge is unending and may, in time, lead us to discover other realms yet unexplored. Welcome to our planet, Earth, a vibrant sphere enveloped in azure nitrogen skies, cradling vast oceans of liquid water and teeming with life. In considering the physical realm, the Earth's surface unfolds to about 7 degrees of curvature, a concept that one can visualize as a series of divinely crafted sticks arranged in a wondrous geometric display. This spinning globe, our shared home, has a rich tapestry woven by human exploration, curiosity, and the relentless quest for understanding. The history of Earth exploration is one filled with endeavors that stretched from its remote corners to interconnected civilizations. Great voyages were embarked upon, traversing the vastness to and from distant lands such as China and Polynesia. One of the pivotal moments in this narrative was the Age of Discovery, typified by Christopher Columbus, whose name resonates through the ages as a symbol of ambition and inquiry. His expedition in 1492, driven by dreams of reaching the lands of the East, culminated in the unexpected discovery of the Americas. Columbus was enthralled by what he termed the enterprise of the Indies. Instead of navigating the familiar coastlines, he dared to traverse the uncharted waters of the Western Ocean, boldly stepping into the unknown. His inspiration came from the ancient mathematician Eratosthenes, who had posited that there existed a navigable sea route from the Iberian Peninsula to the subcontinent of India. However, for Columbus to realize his ambitions, he had to reshape the boundaries of perception. He manipulated the measurements of the Earth's circumference, downplaying its vastness in a way that gave him the confidence to sail boldly westward. This act of perplexing arithmetic, later criticized by scholars at the University of Salamanca, sparked a series of events that would forever alter the course of history. As we progress through the annals of time, we find ourselves in an era where the Earth has been thoroughly mapped and charted, its mysterious edges once veiled and intrigue now revealed. The technologies developed to meticulously explore the Earth, from the depths of the ocean to the peaks of lofty mountains, have now bestowed upon us the opportunity to transcend our planet's bounds. We gaze at Earth from afar, witnessing its majestic, spherical shape and the intricate dance of its continents, a testament to the foresight of ancient luminaries like Eratosthenes, Strabo, and Ptolemy. This intellectual voyage has roots in a city that flourished over 2 millennia ago, Alexandria. Founded by the ambitious conqueror Alexander the Great around 300 BC, this fecund city became the cradle of innovation and enlightenment for nearly 6 centuries. Alexandria's community was an alluring mosaic, its streets bustling with the thoughts and ideas generated by individuals from myriad backgrounds. Macedonian and Roman soldiers, Egyptian priests, Greek aristocrats, Phoenician sailors, Jewish merchants, and diverse travelers from India to sub-Saharan Africa coexisted in an atmosphere of mutual respect, despite the veil of slavery affecting much of its populace. In Alexandria, a culture of erudition was championed. Following his conquest, Alexander fostered respect for varied traditions and laid the foundations for a legacy built upon knowledge. It is said, whether myth or truth, that he descended into the depths of the Red Sea in a primitive diving bell, showcasing an insatiable thirst for understanding the natural world. His reign notably encouraged intermarriage with foreign women and the worship of gods beyond the Greek pantheon, evidencing a progressive openness that paved the way for academic collaboration. Alexandria's urban landscape was a marvel, imbued with vast avenues, sophisticated architecture, and monumental structures. The city stood as a hub for commerce, science, and culture, anchored by the renowned Pharos Lighthouse, one of the 7 wonders of the ancient world. Yet, the pinnacle of Alexandria's legacy lay within its exceptional library, the most celebrated of its time, a sanctuary of knowledge dedicated to the 9 muses. However, the glory of Alexandria did not endure. Over centuries, forces of oppression and fear of learning suffocated the vibrant intellectual life nurtured here, and today's remembrances are but shadows of what once thrived. Yet, as we stand at the cusp of further exploration, looking toward the cosmos with new eyes, the spirit of Alexandria whispers through the ages, urging us to investigate, understand, and honor the universe that cradles our existence. Thus, as we stand on the shores of the cosmic ocean, the journey of understanding our world continues. Each voyage, whether terrestrial or celestial, becomes a testament to our relentless pursuit of knowledge, a bridge connecting past, present, and future, leading us toward the mysteries waiting beyond our fragile atmosphere. We have explored the Earth, now, it is time to reach for the stars. In the quiet whispers of history, the echoes of a magnificent world can still be imagined, where knowledge and culture thrived beneath the watchful skies of ancient Alexandria. This city, more than just a collection of grand columns and sunlit marketplaces, was the epicenter of scholarship, a cradle for ideas that resonated through the corridors of time. Among its splendor, the Library of Alexandria stood as a beacon of human intellect, illuminating the cosmos with insights gleaned from the minds of its greatest thinkers. If one were to gaze upon the surface of the Earth, tilted roughly 7 degrees, spiraling through the vastness of space, they would hardly suspect the tremendous strides that those ancient scholars made in their quest for understanding. Imagine the faces of the students and scholars, hunched over their scrolls, debating the structure of the universe itself. They ventured into the mysteries of the cosmos with unyielding curiosity, seeking to establish order, what the Greeks called cosmos, against the chaotic backdrop of the unknown. The survival of knowledge, however, has often been fraught with peril. Now, as we sift through the remnants of our past, we may stumble upon the dank and forgotten cellars of the Serapeum, a place that once hummed with intellectual energy. This library annex, which was originally a temple, later reconsecrated to the pursuit of knowledge, is a mere shadow of its former self. It holds only crumbling shelves and dust, yet its memory is tangled with that of a glorious era characterized by scholarly brilliance. In this sanctuary of wisdom, the works of such luminaries began to take form. Eratosthenes, equipped with a mere stick and knowledge of geometry, cheekily declared the Earth's size with remarkable accuracy. His methodologies would inspire generations. Hipparchus meticulously mapped the stars, weaving constellations into the stellar tapestry while estimating their luminescence. There was Euclid, a figure who championed geometry and famously remarked, "There is no royal road to geometry," a sentiment that echoed across the ages, underscoring the aspirational journey of learning. Dionysius of Thrace took up the mantle of language, his contributions shaping the way human thought was expressed, while Herophilus revolutionized medicine by determining the brain's role as the seat of intelligence, far before others grasped its significance. Heron of Alexandria breathed life into innovations, crafting steam engines and mechanisms that predated the modern age, while Apollonius's exploration of conic sections laid the groundwork for understanding celestial orbits, knowledge that would not re-emerge for thousands of years. Among these celebrated figures was Hypatia, an extraordinary woman who shimmered brightly in a male-dominated world of sciences, her spirit lingering long after the library's last scroll had faded. Her tragic fate intertwines with the destruction of the library centuries later, marking a grim reminder of the fragility of knowledge. The true commitment to learning shown by the Greek kings of Egypt, who ruled the land after Alexander, was extraordinary. They transformed Alexandria into a vast intellectual garden, nurturing the finest minds. The mighty library was not just a repository but a thriving institute, featuring large research halls dedicated to diverse subjects, botanical gardens, an observatory, and even a zoo, each element carefully designed to stimulate curiosity in dialogue. Books flowed into this sanctuary like rivers into an ocean. Agents were dispatched to scavenge libraries, while authorities dutifully searched incoming ships, not for contraband but for scrolls laden with wisdom. It is believed that the library housed upwards of 500,000 volumes, each painstakingly penned on papyrus. Yet, the winds of time have been unforgiving. A future fraught with war and decline saw the library systematically dismantled until all that was left were scattered fragments, a tragic fate for the vast collection of human knowledge. As we wander through our own age of enlightenment, we often forget that the telescopes, instruments, and methodologies we take for granted were once the dreams of those ancient scholars. The quest for knowledge and the profound wonder of the cosmos continues, yet it is haunted by the silence of what once was, the remnants of a civilization devoted to uncovering the mysteries of existence. Only a shadow of its former self, the echoes of the Library of Alexandria remain, a solemn reminder that the thirst for knowledge is as eternal as the stars that twinkle overhead. Chapter 1: The Shores of the Cosmic Ocean. As the great civilizations of the past turned their gaze toward the heavens, their explorations of the earth unfolded as a collective journey spanning continents and cultures. At the heart of this quest for knowledge stood the fabled Library of Alexandria, a bastion of ancient wisdom, now little more than a ghostly echo stored within the dank and forgotten chambers of the Serapeum. How tantalizing are those remnants of history! Fragments of ancient scrolls ignite our imagination, whispering secrets from a world-long past. Among the library's illustrious archives was a book by Aristarchus of Samos, a bold astronomer who radically proposed that the Earth was not unique, but one of several planets revolving around the Sun, with the stars strewn across an infinite distance. Each assertion he made was profound and true, yet it would take nearly 2 millennia for humanity to reclaim these insights from the shadows of ignorance. This sense of loss, an identified void within our scientific history, makes us ponder the vastness of wisdom that has faded into oblivion. It's as if we held a cosmic card granting us access to the once majestic halls of the Alexandrian library. How many enigmas could we unravel? Imagine the stories of civilizations that vanished, their secrets dormant yet yearning for discovery. Take, for instance, the lost 3-volume history by the Babylonian priest Berossus. His first volume, which purportedly chronicled the span from creation to the Great Flood, estimated a timeline of 432,000 years, about 100-fold the duration conveyed in the Old Testament. The contents of such work are now forever shrouded in darkness. What truths lay therein, buried in time, waiting to resurface? The ancients, with their rudimentary understanding of existence, grasped that the world was ancient, yet their comprehension paled in comparison to the knowledge we have today. They sought to pierce the veil of history, to glimpse the past and glean the tales that could inform their present. What they could only dream of, we now know. The cosmos is not merely old, it is vastly more ancient than ever imagined. As we peer into the vastness of space, we discover our home, a tiny mote of dust, orbiting a nondescript star lodged in an insignificant corner of a distant galaxy. And it is not just a small speck we inhabit, but also a fleeting moment in the grand tapestry of time. It is sobering to realize that the universe, or at least its current incarnation, is approximately 15 to 20 billion years old, a testament to enduring cycles of birth, death, and rebirth that shape cosmic history. This period marks the aftermath of an extraordinary event known as the Big Bang, which birthed our universe from a singular, radiant fireball. In the chaos of that moment, galaxies, stars, and planets did not yet exist. Life and its intricate civilizations were mere fantasies swirling through the primordial ether. The journey from the primordial chaos of the Big Bang to the orderly cosmos we strive to understand represents one of the most awe-inspiring transformations of matter and energy imaginable. As we inch closer to deciphering our place within this extensive framework of existence, it becomes evident that we, as sentient beings, are among the most remarkable transformations to emerge from such cosmic upheaval. We are the distant descendants of that explosive beginning, carrying within us the burning desire to understand the universe while seeking to further mold the fabric of the cosmos that we are an inseparable part of. In this vast canvas of existence, we stand as the custodians of knowledge and seekers of truth. History's ashes whisper tales of heroism and tragedy, of ideas lost and rediscovered, beckoning us to push the boundaries of our understanding even further. Let us remain driven by curiosity and awe, ever determined to explore the wonders of the cosmos, for each question answered leads us into deeper realms of knowledge and holds the potential for new revelations that could forever alter our perception of our place within the universe. We are the inheritors of the ancient quest to comprehend not merely the cosmos around us but the very essence of existence itself. And therein lies our monumental journey. Chapter 2. Section, One Voice in the Cosmic Fugue. One Voice in the Cosmic Fugue, a Tale of Origins and Possibilities. In the beginning, when the cosmos was yet a vast canvas of chaos, the creators of existence looked upon the void and whispered the first incantations of life. I am bidden to surrender myself to the Lord of the worlds. He it is who created you of the dust, spoke the divine presence, echoing through the silent recesses of time. Here, at the threshold of reality, all things found their genesis. Yet, for nearly a millennium, the brilliance of this creation was shrouded in the dark clouds of theological scholasticism. Great minds struggled in the quagmire of dogma, their ideas shackled by the weight of centuries. But like a phoenix rising from the ashes, Charles Darwin emerged in the 19th century. His theories poured new lifeblood into the ancient frame of evolution, breaking the bonds that held humanity's understanding captive. T.H. Huxley captured this moment exquisitely in 1887, recognizing that the invigorated philosophy of evolution was a more truthful reflection of the universal order than any fantastical notions perpetuated by superstition. Darwin articulated a profound perspective, asserting that probably all the organic beings which have ever lived on this earth have descended from some one primordial form. The realization is both humbling and magnificent, a single spark of life fledgling from the primordial dust transformed into the magnificent tapestry of existence we are part of today. Each thriving species is but a note in the vast symphony of life, a harmony guided by the immutable laws of nature alongside the celestial mechanics that govern the movements of the stars. The cosmos, a boundless expanse, reveals a curious community of matter. Every star, from the gentle glow of our sun to the countless distant suns that punctuate the night sky, harbors the same elemental building blocks of life. As William Huggins pondered in 1865, it seems that the universe preferentially scatters the elements, hydrogen, sodium, magnesium, iron, those very foundations of life throughout the stars. Perhaps, he mused, these stellar fires serve as energizing centers for worlds where life may flourish. But who are we, caught in this web of existence? Each of us is a manifestation of our planet's peculiar tapestry. All my life, I have wondered if life exists elsewhere beyond the confines of Earth. What mysteries do those worlds harbor? Do beings from distant planets share the same organic molecules, the intricate carbon chains, that define our own existence? Or does the universe weave wondrous adaptations tailored uniquely for diverse environments? As I reflect on life's grandeur, I journey through the dark interstellar declines filled with clouds of gas and organic matter. Radio telescopes have unveiled the existence of myriad organic molecules floating among the stars, suggesting a cosmic abundance of the very essence of life itself. And so we ponder, is the emergence of life merely a fortunate accident, or is it an inevitability written in the stars? On some of the billions of planets orbiting the stars in the Milky Way galaxy, life may never arise, existing merely in dormant potential. On others, life may spark to existence, only to flicker out, never progressing beyond its simplest forms. Yet, on a select few worlds, innovation and intelligence could one day burgeon, crafting civilizations that echo through time. Often, I hear whispers of how fortunate Earth is, with its temperate climate, liquid water, and breathable atmosphere. While it may seem like a stroke of cosmic luck, we must challenge this narrative. We, as Earthlings, are perfectly adapted to our environment because our lineage is that of survival. The organisms that thrived shaped our evolution. Our existence here is a consequence of billions of years of fine-tuning and adaptation. Ultimately, all life shares a common thread, an organic chemistry and a rich evolutionary heritage that ties us together like notes in a symphonic masterpiece. And just as the stars twinkle in the sky, so too do the stories of innumerable worlds spiral into infinity. In the grand cosmic fugue, we are but one voice, striving to understand the symphony of existence that envelopes us. Our search for life beyond our own is not just a quest for answers, but a profound inquiry into the essence of who we are, and of the limitless possibilities that the universe has to offer. As a result, our biologists are profoundly limited. They focus solely on one facet of biology, tuning into the solitary melody of life that echoes within a narrow frequency. The question lingers, is this fragile and reedy tune the only voice that resonates across the vastness of thousands of light years? Or could it be that there exists a complex cosmic fugue, a grand symphony woven together with themes and counterpoints, dissonances intermingled with harmonies, an orchestra of a billion diverse voices participating in the eternal music of existence throughout the galaxy? To demonstrate this, let us ponder a poignant tale, one that illuminates a brief yet significant phrase within the grand symphony of life on Earth. In the year 1185, during the twilight of an era draped in chivalry and honor, the Empire of Japan was under the tender gaze of a 7-year-old boy named Antoku. Though young in years, he was cast in the role of the nominal leader of the Haika clan, an illustrious group of samurai embroiled in a tumultuous and grim saga against their rivals, the Genji clan. This conflict wasn't born of mere animosity. Each clan laid claim to a storied ancestral heritage that elevated their right to rule the imperial throne. The climax of this blood-soaked tale unfolded on April 24, 1185, in the waters of the Japanese Inland Sea during the decisive naval battle of Danoura. The Haika found themselves tragically outnumbered and outmaneuvered, like a single note trying desperately to rise above a cacophony of sound. On that day, many brave samurai fell, cut down by enemy blades, while the surviving warriors faced a fate even grimmer. They surrendered to the depths, abandoning their mortal forms. Gripped by despair but resolute in her love, Lady Ni, the grandmother of young Entoku, vowed that neither she nor her beloved grandson would fall into the hands of their foes. What next transpired is immortalized in the haunting verses of the tale of the Haika. The likeness of young Entoku was striking. He bore an otherworldly beauty, with an aura that seemed to glow softly, his long, flowing black hair cascading down his back. But beneath that radiant surface lay the storms of youth, a mixture of confusion and fear reflected in his wide eyes. He turned to Lady Ni, asking softly, "Where are you to take me?" With tears carving trails down her weathered cheeks, she gathered the child close and bound his long hair away from his face, her heart heavy yet determined. Blinded by sorrow, Antoku clasped his delicate hands together, directing his wishes to the deities, first casting a farewell to the east, to the sacred god of Ise, before whispering the Nembutsu, a reverent prayer to Amida Buddha in the west. In a final embrace, Lady Ni whispered, "In the depths of the ocean is our capital," and together, they succumbed to the engulfing embrace of the waves. The defeat of the Haika was not merely militaristic, it marked the tragic extinguishing of a once flourishing lineage, the annihilation of their entire naval fleet. Only 43 women of the imperial court emerged from the chaos, reduced to mere specters of their former grandeur, forced to barter flowers and trinkets to fishermen plying their trade near the mournful waters. With this, the legacy of the Haika appeared to fade into obscurity. Yet, memory can be a resilient flame, and from the ashes of tragedy rose a flicker of remembrance. Countless years down the line, a motley crew of the surviving ladies-in-waiting and their fishermen descendants organized an annual festival to commemorate the battle, a tribute engraved in the annals of their collective consciousness. To this day, on the 24th of April, fishermen don hemp garments and black headgear, making the pilgrimage to the Akuma shrine, the mausoleum of their drowned emperor. There, they partake in a theatrical retelling of the fateful events that transpired during the Battle of Danoura, an homage to honor their lost kin. Whispers across the generations spoke of ghostly samurai armies, restless spirits laboring to bail the sea, persisting in their quest to cleanse it of the bloodshed and humiliation of their defeat. Local lore holds that the Haika samurai eternally wander the ocean's floor, transformed into crabs. Indeed, within these briny depths dwell crabs who sport uncanny markings on their shells, patterns and indentations reminiscent of a warrior's face. When fishermen catch these eerie crustaceans, they do not partake of them as sustenance, rather, they gently return the samurai crabs to the sea, honoring the somber legacy of Danoura. Yet this legend introduces us to an intriguing question: how does a crab come to bear the visage of a warrior upon its shell? The answer reveals a beautiful intertwining of nature and humanity. The patterns on the crab's carapace are not mere happenstance but represent a peculiar interplay of inheritance. Just as in human lineages, crabs boast a variety of hereditary lines, somewhere among their distant ancestors, a crab may have emerged that bore a resemblance, however slight, to a human face. Even before the fateful events of Danoura, fishermen may have felt an uncanny connection to such a crab. Choosing to release it instead of consuming it sparked an evolutionary dance, a life preserved simply for being different. Consider the fate of a crab with a conventional carapace: likely, it would be devoured and efficiently move into irrelevance. But for that one unique crab, blessed with a shell that evoked a semblance of a face, the fisherman would cast it back into the depths. Thus began a generational survival, the continuation of lineage defined not solely by the harshness of survival, but by the subtle bond of memory, a legacy echoed through time. As a consequence of such stories, our biologists remain profoundly limited. They study within confines, observing isolated instances of life, unable to fathom the intricate harmonies and variegated narratives woven through every thread of existence. Understanding the greater cosmic fugue, the multitude of voices that coalesce to create the vibrant music of life, remains ever elusive, but the tapestry enriches with every tale we tell. The concert of existence is grand, it beckons us to listen more intently and to recognize that the murmurs of our world echo beyond the realms we can see and know, involving verses both seen and unseen, yet to be discovered. One voice in the cosmic fugue. In the vast expanse of Earth's intricate biosphere, there exists a narrative that often goes unnoticed, a tale of selection, adaptation, and the insidious influence of human desire on nature. As we examine the realm of biology, a stark revelation emerges: our understanding is profoundly limited, bounded by the constraints of both nature and our own creation. This dichotomy is especially vivid in the tale of the Haika crab, a small creature that, by the hand of fate and the whims of fishermen, evolved to where its lineage proudly, donned in carapaces that eerily resembled the fierce visages of samurai. Yet underlying this evolution lies a story of survival dictated not by the crabs themselves, but by the forces external to them. As generations of fishermen cast their nets along the coasts of Japan, they unknowingly favored those crabs whose shells bore patterns akin to warrior masks. The evolutionary paths diverged, giving rise to a striking population of crabs that wore the appellation of samurai. In this story, the crabs did not yearn for this transformation, their existence was molded by the hands of those who sought beauty or perhaps superstition in their catch. This phenomenon, an echo of what is known as artificial selection, reflects humanity's long-standing role as curator of life. As we delve deeper into the history of agriculture and domestication, it becomes evident that our interplay with the living world has always been one of control and manipulation. For millennia, we have wielded the power of choice, shaping the destinies of myriad species that now populate our farms and kitchens. But alas, the question arises: did these organisms once roam the wild unrestrained, or are they, by and large, shapes crafted in the crucible of human desire? The truth is both poignant and stark. 10,000 years ago, dairy cows and domesticated dogs did not exist in forms recognizable to us today. The earliest ancestors of these revered companions and crucial agricultural staples bore little resemblance to their offspring. Humans selected and bred certain varieties for their desirable traits: docility in dogs, bounteous milk supply in cows, or the vibrant productivity of crops. We harnessed the unrelenting force of genetics, ensuring that those traits we valued flourished while others faded into oblivion. Thus, the process of artificial selection becomes a linchpin in our understanding of life's complexity. It illustrates a central idea: traits can be inherited, and certain varieties will thrive at the behest of those who guide their reproduction. Over time, the outcome of this selection becomes a vivid tapestry of life, where abundance exists alongside extinction, a testament to human ingenuity and, concurrently, a warning of our hubris. Yet, as we hone our ability to create and manipulate, we must not overlook the natural mechanisms that govern life's canvas. Natural selection, an equally profound counterpart, wields its own brand of artistry over the generations. Life, as evidenced by the fossil record, evolves in tandem with environmental shifts, revealing a world vastly different from the one we now inhabit. Species that once roamed in the millions have vanished, serving as a reminder of our planet's ceaseless march toward change. Far more species have succumbed to the inexorable passage of time than those that endure today, marking these extirpated forms as the discarded experiments of evolution. In the fervent clash between life's competitors, the echoes of extinction reverberate louder than the hymns of survival, reminding us of the fragility inherent in the dance of existence. Even within the flows of domestication, the pace is staggering. Consider the rabbit, a creature whose domestication rooted itself in folklore, as French monks raised them under the premise that their newborns could be classified as fish, exempt from dietary restrictions. In a similarly curious fashion, the evolution of coffee from humble beans to the globally celebrated beverage we savor today takes mere centuries. The rapid evolution of the sugar beet and the still nascent domestication of the mink further illustrate our complex relationship with these beings we call companions and crops. In less than 10 millennia, human intervention in breeding has radically transformed sheep, escalating their wool production from a scant kilogram to an astonishing 20 kilograms, underscoring our capacity to reshape life as we know it. This intricate narrative, woven with threads of artificial selection and underscored by the relentless forces of natural selection, invites us to reflect on our role and responsibility in this grand cosmic fugue. As humans continue to perturb the natural order, we must ponder the consequences of our choices not merely as stewards of our planet but as architects of life's future. Thus, the crabs, with their warrior patterns, become more than mere victims of circumstance. They embody the shared journey of all living things as we navigate the delicate balance between creation and extinction, persistence and manipulation. And therein lies the ultimate truth: our biologists, like the natural world they strive to understand, remain profoundly limited, ever seeking answers while crafting a destiny intertwined with forces beyond our immediate grasp. In a world where the intricate threads of existence knit together the tapestry of life, biologists endeavor to comprehend the profound mysteries underlying the biosphere. Yet, they find themselves strikingly limited in their understanding. They observe the surface of nature's unyielding design and see crabs with their beautifully patterned carapaces and the shimmering cilia that adorn their shells, a testament to millions of years of evolutionary artistry. They quantify the miracle of life in more familiar terms, such as the staggering volume of milk produced by cattle during their lactation cycles, which can fluctuate from a few hundred to millions of cubic centimeters. This ability to produce is not merely a statistic, it is a vivid expression of life's complexity and adaptability. If we can witness such rapid transformations through artificial selection, where humans manipulate traits to breed specific characteristics, one must ponder the magnitude of natural selection, working diligently over billions of years. What wonders could such a force create in the vast expanse of time? The answer lies in the breathtaking diversity of life that flourishes around us, a myriad of forms, colors, and behaviors born from the relentless dance of evolution. To declare that evolution is a fact, not a theory, is to acknowledge the awe-inspiring processes that have sculpted the living world. The bedrock of this understanding was laid by the monumental work of Charles Darwin and Alfred Russel Wallace, whose insights into the mechanics of evolution revealed natural selection's pivotal role. More than a century ago, these pioneers elucidated that nature is abundantly prolific. It gives rise to a staggering number of organisms, far exceeding the capacity of the environment to sustain them. In this struggle for existence, nature becomes the ultimate arbiter, favoring those variations that, by chance, prove more suited to survival. Here, mutations act as the raw material of evolutionary change, subtle yet vital shifts in heredity that can lead to the emergence of entirely new species over time. Within diverse cultural narratives, we find echoes of these evolutionary principles. In the Mayan creation story contained within the Popol Vuh, life is described as a series of near misses by gods experimenting to create beings. The divine attempts faltered, producing lower animals until the unsuccessful trials culminated in monkeys, the penultimate effort before reaching the pinnacle of creation. Similarly, ancient Chinese mythology tells of humans emerging from body lice that belonged to the god Pan Ku, depicting an unexpected genesis. Although these tales diverge from the rigorous framework of Darwin's and Wallace's theories, they nonetheless resonate as anticipatory glimpses into the mind of evolution, a theme echoed by early philosophers like Democritus and Empedocles, who began to probe life's complexities in a nascent form of scientific inquiry. Darwin crystallized the heart of this theory in his seminal work, The Origin of Species, proclaiming, "Man does not actually produce variability, he only unintentionally exposes organic beings to new conditions of life, and then nature acts on the organization and causes variability." Humans, though capable of guiding evolution through selection, are mere participants in a vast and intricate natural process. Natural selection operates independently, unaffected by human whims. It selects variations that confer an advantage, enabling a delicate balance to tip in favor of the fittest. In the late 19th century, T. H. Huxley, a stalwart champion of evolutionary thought, likened the revelations of Darwin and Wallace to a flash of light in a darkened world. He recalled his own epiphany upon grasping the elegant simplicity of their theories, likening it to the surprise of Columbus' companions realizing the implications of their voyage. While the struggles of existence and the evidence of variability were well known, it took the brilliance of Darwin and Wallace to illuminate the path leading to a deeper understanding of life's origins and transformations. Despite these revelations, many still find themselves scandalized by the implications of evolution and natural selection. Throughout history, our ancestors marveled at the artistry and precision of life, often attributing its elegance to a divine craftsman. Concepts such as the intricacy of a crab's carapace or the functionally fluid biology of livestock were viewed with reverence, as if they were fixed markers of an unchanging world. Yet, as we peel back the layers of time, we uncover a cosmos in constant flux, where every biological form is a testament to an age-old process of change, where every strand in the fabric of life is woven by both chance and necessity. As we continue to navigate the wonders of our natural world, we are reminded that the journey of understanding is just as essential as the truths we seek. Evolution is not merely a chapter in a book but a grand narrative, a cosmic fugue in which every life form plays its part in the symphony of existence. Within this profound, often perplexing, and endlessly beautiful tale lies the essence of life itself, an evolving narrative that invites us to consider our place in the universe, both as witnesses to the marvels of nature and as participants in the unfolding story of life. Let us proceed forward, open to the mysteries yet to be revealed, as we explore the intricate web of life that has been crafted over unfathomable eons. A symphony of life, an exploration of nature's design. In the vast tapestry of existence, the world revealed itself in patterns of exquisite beauty, each thread meticulously woven through ages of evolution. Crabs, adorned with intricate designs on their carapaces, owed their survival not only to the aesthetic wonders of nature but to an underlying purpose. Each color and shape was an investment in their survival, intricately linked to their responses to predators, their mating rituals, and their environments in which they thrived. These patterns hinted at a grander design, an evidence of a great designer, a phrase that resonated profoundly through the ages. Yet, as complex and seemingly flawless as the natural world appeared, one could not help but draw comparisons to the intricate mechanisms created by human hands. A simple, single-celled organism, a paramecium, perhaps, was a marvel of biological engineering, flawlessly executing its functions with efficiency that surpassed even the finest pocket watch. The gears and springs of such timepieces, no matter how finely crafted, could not assemble themselves from the remnants of older, less effective mechanisms. Similarly, one wondered how the diverse forms of life on Earth could emerge purely from the random interactions of atoms and molecules. Surely, the undeniable complexity of life inferred a guiding hand, a designer who orchestrated the symphony of existence. However, with these comforting notions came an unsettling contradiction. Why did the fossil record tell a tale rich in trials, errors, and failed experiments? Every living organism, marvelously fashioned, invoked the question, should not a supremely competent designer have conceived of life as a complete array from the very start? Instead, the whole of nature displayed hints of an artist still perfecting their craft, a process fraught with missteps and revisions, traits one might associate with an inefficient creator rather than a flawless one. It is in this paradox where the ideas of Darwin and Wallace stirred the dust of convention, introducing the concept of natural selection, a mechanism of adaptation and change that plays its own unique melody in the symphony of life. In this exploration of life's complexity, I found myself propelled back to my own formative years as a college undergraduate in the early 1950s. I was fortunate to step into the hallowed laboratory of H. J. Muller, a luminary in the field of genetics, one who uncovered the profound effects of radiation-induced mutations on living beings. It was he who piqued my interest in the Haika crab, his illustrations of artificial selection igniting the spark of curiosity within me. Hours turned into months as I devoted myself to studying the fruit flies known scientifically as Drosophila melanogaster, the charming little creatures with their big eyes and fluttering wings. The method of inquiry was personal and tactile. We kept them in pint-sized milk bottles, cross-breeding varieties, observing with anticipation as new forms emerged from gene rearrangement and the effects of both random and induced mutations. Day by day, the subtle dance of life unfolded before me. The female flies deposited their eggs onto a sticky base of molasses while we, the eager observers, waited patiently for nature to work its magic, small cycles of life transforming before our eyes. Then came a day that would forever shift my understanding of genetics. As I peered through a low-powered binocular microscope, immersing myself in the world beneath the lens, I was tasked with examining a newly arrived batch of adult flies, momentarily subdued by ether. As I carefully sorted through the variations, preparing to categorize the small nuances, perhaps red eyes, or the presence of neck bristles, my heart raced with surprise. Among familiar forms emerged something utterly extraordinary. This was no mere variation, it was a wholly distinct creature, complete with prominent wings and long, feathery antennae, a new form that seemed to defy the paradigms established by Muller himself. I was awestruck by the wonder of evolution laid bare within my grasp. Here was evidence, a major evolutionary change manifest in a single generation, something Muller asserted was virtually impossible. My heart was heavy with the weight of this discovery as I made my way to his office, where he laboriously worked under the dim glow of a solitary lamp. Knocking softly on the door, I was met with the muffled invitation to enter. As I stepped into that darkened room, the air felt charged with anticipation. I swallowed hard, mentally rehearsing my explanation, and stumbled through the narrative of my discovery, a different type of fly, a breathtaking example of life's incredible potential for change. As my voice trembled in the quietness of the room, I was acutely aware of the legacy of inquiry that brought me here, of the paths threading back through history, and the intimate relationship humanity shares with nature. This moment, this dilution of mere chance into something greater, was not merely an isolated incident but rather a testament to the wondrous complexity of evolution. In that darkened laboratory, under the glow of a lamp that illuminated the intricate dance of life, I found not just a superior variety of fly, but a glimpse into the very depths of the collective quest to understand the cosmic fugue, a dynamic, unfolding masterpiece in which every organism, every mutation, contributes to the beautiful symphony of existence. Each note played contains the weight of history, trials endured, and the delicate balance between design and chance, beckoning us ever closer to the resonance of life itself. The laboratory was a sanctuary of inquiry, a world unto itself, where the mystique of life unfolded amidst microscopes and petri dishes. The air hung thick with the evaporated essence of countless experiments, a mixture of expectation and the eerie silence that clung to those who sought answers to life's most profound questions. I was lost in thought, contemplating the universe's intricate patterns when an unexpected discovery jolted me back to reality. Of uniform, fine down, a creature emerged, strikingly different from the familiar world around it. It wasn't merely the volume of milk from the lactating cattle that caught my attention, it was something more elusive, a playful hint of chaos erupting from the order of nature. As I stood, pondering the delicate balance of existence, I believed I had stumbled on tangible evidence of a great designer guiding the hand of evolution. Does it look more like Lepidoptera than Diptera? The gentle voice of Muller broke through my reverie, his face glowing in the dim light, hinting at the unexpected excitement he felt. The question unfurled like a riddle, leaving me momentarily dumbfounded. Lepidoptera, the order of moths and butterflies; Diptera, the flies. But what did it mean to distinguish? I nodded slowly, glumly admitting my ignorance. With the flip of a switch, Muller illuminated the space, and his eyes sparkled with the joy of a teacher revealing a profound truth. He spoke of the laboratory's uninvited guest, a moth that had become a master of adaptation within Drosophila genetics laboratories. The tale he recounted was humbling, a moth that cared little for fruit flies, for it sought only their ambrosial molasses. In the fleeting seconds when a technician would pause to breach the milk bottle to facilitate a feeding frenzy of fruit flies, the agile mother moth would seize the moment, dive bombing into the molasses to lay her eggs. What I had anticipated as a discovery of grand proportions was a mere footnote in nature's inexorable narrative, a charming instance of adaptation, alive and thriving as the product of millennia of micromutations and natural selection. The secrets of evolution, Muller mused, his voice low, full of contemplative gravity, are painted in strokes of death and time. An orchestra of life forms imperceptibly succumb, leaving behind those best suited to their environments. Yet, the ultimate challenge lies in grasping the true passage of centuries and epochs. How can we possibly fathom 70 million years? Our lifetimes are but fleeting whispers in the cosmic wind, like butterflies flitting through a single summer's day, ignorant of the vast tapestry of time stretching beyond our ephemeral existence. What transpired on Earth could reflect the narrative of life's evolution on other worlds. However, the unique chemistry of earthly proteins and the particular intricacies of brains suggest that Earth's story is, in truth, exceptional among the stars. Around 4.6 billion years ago, our planet coalesced out of primordial gas and dust. We glean from the fossil record that life's genesis was swift, potentially unfolding within 4.0 billion years, cradled in simmering ponds and untroubled oceans. Yet, the first life was not the sophisticated cell but rather a simplicity lost to time. The earliest stirrings were born of chaos and chance, as elements of the primordial atmosphere came to life under the tempest of lightning and the warm embrace of the sun's ultraviolet light. Simplistic hydrogen-rich molecules danced, breaking apart under energy's urging, weaving themselves into an organic tapestry over eons, forming an ever more complex soup. In a monumental accident, one molecule emerged capable of self-replication, creating crude copies of itself from the building blocks surrounding it, a nascent entity that would evolve into the master architect of all earthly life, deoxyribonucleic acid, or DNA. Shaped like a spiral staircase, DNA cascades down its twisted ladder, each rung a molecule known as a nucleotide. The 4 nucleotides form the lexicon of life, articulating the hereditary instructions that delineate every organism's unique identity. From the tiniest bacteria to gargantuan whales, each life form carries a distinct narrative written in the universal language of genetic code. A mutation, defined as a change in one of these painstakingly crafted nucleotides, might have ripple effects through generations. Most mutations, alas, are detrimental, disrupting function in coding for enzymes that fail chemistry's tests. It takes patience, an expanse of time, for evolution to scaffold upon even the slightest beneficial mutation, yet it is these improbable occurrences that propel the grand narrative of evolution forward. 4 billion years ago, Earth was a molecular Garden of Eden, teeming with the potential for life. As I took in this enchanting saga, the intricate dance of molecules and adaptations told a larger story about the interconnectedness of existence, weaving a cosmic fugue that echoed through infinity. It was then I understood our part in this grand design, a symphony in a universe far beyond any solitary note, where every mutation, however minor, resonated with the whispers of creation and the evidence of a great designer steering the evolution of life's boundless tapestry. Title: The Cosmic Elegy, A Journey Through Time and Existence. In the grand theater of the cosmos, where the stars whisper of creation, a magnificent tale unfolds, one that is interwoven with the essence of life itself. It begins not with the flourish of grandiose organisms but in the delicate dance of simple molecules, a primordial symphony echoing in the void. In those early days, there were no predators nor complex hierarchies to speak of, it was a time of innocence. Molecules, the building blocks of existence, began their laborious journey of reproduction. They worked inefficiently at first, competing against one another for essential building blocks, atoms and compounds that would lay the foundation of life. Each molecule left behind hints of its existence, crude copies that served as the faltering first steps of an evolutionary juggernaut. As eons ebbed away, these molecular artisans grew more adept. Through the interwoven processes of reproduction, mutation, and the natural selection of the least efficient varieties, evolution took root even at the most microscopic levels. Time became a sculptor, chiseling away the rough edges of simplicity, giving birth to specialized functions. It was in this ceaseless flux that a remarkable union occurred, molecules began to coalesce, forging primitive but revolutionary collectives that would ultimately evolve into the first cells. These cells became the architects of their own destinies. In green plant cells, tiny molecular factories known as chloroplasts emerged, miraculously converting sunlight, water, and carbon dioxide into carbohydrates and oxygen, breathing life into the world. Meanwhile, the mitochondria in blood cells became the ever-watchful sentinels, adept at harvesting energy from the food we consume, their lineage tracing back to a time when they were once free-living cells in their own right. Fast forward to 3 billion years ago, and we witness a remarkable transformation, a coalition of single-celled organisms bound together not out of survival, but perhaps due to a chance mutation that prevented their division after replication. This event ushered in the first multicellular organisms, marking a monumental leap in complexity. Herein lies the truth of our biological essence. Every cell in our body is not merely an individual unit but rather a harmonious commune, a meticulous assembly of once free agents merged for the greater good. With a staggering 100 trillion cells comprising our beings, we are, indeed, a multitude, a living testament to ancestral cooperation. Yet this evolutionary tapestry did not rest long. Life, in all its countless forms, was destined to evolve further. 2 billion years ago emerged a revolution in genetic exchange, the inception of sexual reproduction. Before this pivotal moment, the birth of new varieties relied heavily on slow, random mutations, a painstaking letter-by-letter evolution of genetic codes. But with the dawn of sex, a profound alchemy began. Organisms could now exchange vast swaths of their DNA, paragraphs, pages, entire books of genetic information. This newfound richness in diversity propelled evolution forward with exhilarating speed. Those who refused to engage in this intricate dance of life faced extinction, making sexual reproduction an evolutionary imperative, a principle that resonates with us even today. By 1 billion years ago, the landscape of Earth had profoundly transformed. Green plants, working together in vibrant ecosystems, initiated a breathtaking shift by producing molecular oxygen. The oceans vibrated with life, coated in green hues, while the atmosphere, once rich in hydrogen, began to fill with oxygen, an invisible conclusion of biological processes reshaping the world. Yet this gift of oxygen proved a double-edged sword. While it breathed life into countless organisms, it also threatened unprotected organic matter with oxidative devastation. The transformation to an oxygen-rich atmosphere became a crucible of survival. Many organisms succumbed to this peril, unable to adapt to the new conditions. Nevertheless, certain primitive forms, such as the infamous botulism and tetanus bacilli, managed to find refuge in oxygen-free realms, proving that life can withstand the most formidable challenges. Nitrogen, far more chemically inert and less hazardous, became the backdrop of our atmosphere, a silent witness to life's endeavor. Remarkably, 99% of Earth's atmosphere is of biological origin. It is, in essence, the sky painted by life itself. For the majority of the past 4 billion years, life's canvas was dominated by microscopic blue-green algae, their presence an incredible testament to endurance. Yet, some 600 million years ago, a dramatic shift took place, the Cambrian explosion. Suddenly, a dazzling diversity of lifeforms burst forth, breaking the algae's monopoly of the oceans. This proliferation hints at life's tendency to emerge rapidly on suitable planets, suggesting a possible inevitability of existence in the universe. However, for 3 billion years, life remained primarily confined to simple forms, highlighting an intriguing paradox. While the origin of life seemed relatively straightforward, the evolution of complex organisms with specialized functions proved dauntingly challenging. Perhaps, amidst this vast continuum, there lies the exquisite evidence of a great designer, the architect of life's intricate patterns. Ultimately, our journey through this cosmic fugue invites reflection on the profound interconnections that bind all living beings. Life is not merely a series of independent events, rather, it is a grand narrative where molecules, cells, and organisms join together. From the invisible dance of atoms to the majestic complexity of the human form, each bears witness to the remarkable saga of existence, a story still unfolding under the watchful gaze of the universe, echoing through time and beyond. The design of life, a cosmic story. In the vastness of the universe, amidst swirling galaxies and shimmering stars, our planet Earth dances in its orbit, a singular jewel suffused with life. It was once barren, just like the countless other worlds that hang in the night sky, painted vivid against a canvas of cosmic possibility. Yet, there are worlds, much like ours, where microbes thrive in the shadows, though giants of the land and sea are nowhere to be seen. And so, the quest to understand life and its intricate structures began, leading me inexorably to the notion of a great designer, whose artistry can be observed in every leaf, every cell, and every creature. Around 500 million years ago, our oceans transformed into a vibrant theater of life. During the Cambrian explosion, a remarkable surge of biodiversity erupted like never before. The waters teemed with the vibrant dance of creatures, where vast herds of trilobites roamed, their bodies akin to intricately crafted machinery. These strange beings, resembling oversized insects with their segmented bodies, engaged in a predator-prey ballet on the ocean floor, employing crystalline structures in their eyes designed to sense the light filtering through the water. Yet, as time flowed on, these trilobite kin became but a whisper in the fabric of history. None have graced the earth for over 200 million years. In this ancient dance of time, one cannot help but recognize the transitory nature of species. Each era welcomed forms of life that flourished momentarily before vanishing into obscurity. Those who walk the earth today would find no familiar traces of their distant ancestors in the stones, for the expansive realm of life has been in a constant state of flux. Natural selection, with its merciless precision, sculpted shapes that aligned with changing ecosystems, a process as beautiful as it is ruthlessly efficient. Before the Cambrian explosion, life appeared to unfold in an almost languorous manner. Fossil records reveal a gradual progression of simple organisms, their soft bodies leaving little behind as evidence. The story of life unfolds slowly, like a whisper from ancient times as we peer further into the Earth's distant past. Yet, following that crucial explosion, mirroring the flare of fireworks erupting in a night sky, exquisite adaptations erupted with breathtaking speed. Fish took their first glimmers in the depths, the first vertebrates began to claim their place in the pools and streams. Once constrained to the oceans, plants began their audacious conquest of terrestrial landscapes, sending up tendrils of green toward the sun. Soon after, the first insects punctuated the air with their delicate wings, heralding a new age of life, while creatures like lungfish transitioned gracefully between aquatic and terrestrial realms. The evolutionary tapestry became richer, and soon the first trees stretched skyward, claiming their kingdom in the bustling agora of life. With each stroke, the narrative grew more intricate and alive. The age of reptiles dawned, dinosaurs dominated the landscape while birds began to soar through the skies. Yet, amidst all this, mammals quietly emerged, laying the groundwork for our eventual lineage. It is a remarkable chain of events, an unfolding drama with less than 10 million years separating us from the first human-like creatures, whose burgeoning brain size foreshadowed the rise of true humanity just a few million years ago. As humanity ventured forth, we discovered the forests that cradled our ancestors. An innate bond formed between us and the towering trees, those sentinels of time that reached toward the heavens. Trees, magnificent machines powered by sunlight, absorb water from the roots and carbon dioxide from the air, fulfilling their essential purpose through photosynthesis. In their quiet competition for light, they engage in an unspoken rivalry, each striving to outstretch its neighbor, bending and swaying in languid grace. Humans, the ultimate beneficiaries of this green network, have always relied on the finesse of plants for nourishment. While we might appear as apex predators in the animal kingdom, we are, in a profound sense, parasites to the very life forms that sustain us. As we consume leaves and fruits, our own bodies convert carbohydrates into energy, a process elegantly intertwined with the life cycles of the plants. We inhale the oxygen they release, and in our becoming, we exhale carbon dioxide, completing a grand, mutual exchange, a planet-wide cycle of life performed on a stage suspended in the cosmos, illuminated by a distant sun, 150 million kilometers away. Amidst the vast array of life, one sees the artistry inherent in each organism. Though tens of billions of organic molecules exist, only a select few are engaged in the fundamental activities of life. Repeating patterns, illuminating adaptations, speak to the ingenuity of evolution, symbolizing nature's conservative, yet breathtakingly creative, approach. In every structure of every living being lies a harmony of function and design that echoes the existence of a great designer, an enigmatic force behind the tapestry of life. This dance of evolution resonates throughout the cosmos, reminding us of our ephemeral existence against the backdrop of timelessness. Just as planets devoid of grandeur await their own stories, we find our narrative intertwined with the singular journey of life, forever striving to grasp the understanding of our origin in the grand cosmic fugue. The exploration of existence stands as one of humanity's noblest endeavors, a journey colored by curiosity and wonder that leads us ever onward, driven by the question, are we, too, not the work of a great designer? Understanding cosmology, a cosmic dance of life and matter. In the grand tapestry of the universe, the interwoven structures of organisms resonate harmoniously with their functions, a melodic testament to a great designer whose intricate handiwork is palpable in every living creature. Imagine, if you will, a distant planet drifting in the cosmos, a world teeming with microbial life, yet devoid of the monumental beasts and lush vegetation that populate Earth. In that stark contrast, we discover something profound about life itself. From the simplest microbe to the towering oak tree, the proteins that orchestrate cellular chemistry and the nucleic acids carrying the hereditary instructions are fundamentally identical. Indeed, at our deepest roots, an oak tree and a human being share a common ancestor, united by the very essence of biological life. The living cell, a marvel of design, is as complex and awe-inspiring as the galaxies swirling in the night sky. Over 4 billion years of evolution have painstakingly sculpted the sophisticated machinery of the cell. Envision this ancient process: fragments of food, broken down and transformed, become the essential components of life. The white blood cells patrolling our bodies could trace their lineage back through time, their origins rooted in the humble remnants of yesterday's meals. But how does this wondrous transformation take place? Let us delve deeper into the intricacies of cellular architecture. Within the confines of a cell lies a labyrinthine structure, a subtle universe of activity that maintains order, transforms nutrients, stores energy, and prepares for replication. Peering into the microscopic realm, we would witness a bustling scene of molecular specks, proteins in a frenetic dance, engaging in their diverse roles. Among them, enzymes majestic in their purpose stand out, executing the cell's chemical reactions with precision. Each enzyme is akin to a skilled assembly line worker, specializing in a specific task, whether it be constructing nucleotides or dismantling sugars to harvest energy, the very currency that fuels the cellular machinery. Yet, these enzymes, though vital, do not make decisions autonomously. They are mere agents executing a grand plan, relying upon directives from the authoritative molecules, the nucleic acids. Nestled in the depths of the cell, within a forbidden city known as the nucleus, these boss molecules reside, issuing intricate instructions that guide cellular functions. Imagine plunging into the nucleus itself, only to find a chaotic explosion of twisted strands and coils, a veritable spaghetti factory, alive with the essence of life. Here lies the DNA, the blueprint of existence, and its messenger RNA, faithfully relaying commands to the rest of the cell. Every twist and turn in these molecular structures embodies 4 billion years of evolution, encapsulating a wealth of information that delineates the blueprint for cellular creation. The information inscribed within human DNA, if transcribed into ordinary language, would unfurl across 100 hefty tomes, revealing the secrets of life itself. DNA, with its iconic double helical structure resembling a spiral staircase, serves as the language of life. Each step along this staircase represents a sequence of nucleotides, the fundamental building blocks of genetic instruction. During reproduction, the DNA helices gracefully unwind, assisted by a dedicated uncoiling protein, setting the stage for the synthesis of identical copies. Nearby, floating in the viscous milieu of the nucleus, lies a pool of nucleotide building blocks, ready to take their place in the newly formed strands. As the unwinding progresses, a remarkable enzyme, DNA polymerase, orchestrates the accuracy of replication, ensuring that each copy is nearly flawless. Should an error occur, a cadre of specialized enzymes stands ready to mend the mistake, snipping out the incorrect nucleotide and replacing it with the correct counterpart. This molecular machinery exemplifies the complexity of life, wielding powers that ensure fidelity in the very fabric of heredity. Moreover, nuclear DNA does not simply replicate itself, it serves as the conductor of life's symphony, directing cellular operations and orchestrating metabolism. It synthesizes messenger RNA, which travels beyond the nucleus into the cytoplasm, delivering precise instructions that control the construction of enzymes at the exact moment and in the designated location. When the composition is complete, a solitary enzyme molecule emerges, ready to calibrate a specific biochemical process that sustains life. The human DNA molecule stretches out like a ladder, a billion rungs long, but among these vast combinations of nucleotides lurk countless nonsensical sequences that yield proteins devoid of function. Just as planets drift alongside barren satellite worlds, life on Earth flourishes through a symphony of proteins orchestrating the chemistry of life and nucleic acids carrying the instructions woven into the very fabric of existence. As we stand humbled before the intricacies of life, we are reminded that every organism, from the tiniest microbe to the most complex human, reflects a narrative of evolution crafted by time, chance, and perhaps, the whisper of a great designer. Each heartbeat, each breath, and each biological process is but a note in the cosmic fugue, harmonizing with the rhythm of the universe, revealing profound mysteries waiting to be understood in the grand design of cosmology. One voice in the cosmic fugue. In a universe scattered with innumerable planets, vast stretches of space lie inhabited solely by a vibrant tapestry of microbes, the echoes of life that have mastered existence without the accompaniment of mighty beasts or towering trees. Each planet, like an artist's canvas, presents a unique palette of biological potential, yet, on Earth, the biological savants, proteins and nucleic acids, conduct the intricate symphony of cellular life. These remarkable molecules have evolved through untold epochs to become the very architects of complex organisms like ourselves. The artistry of life's design rests on a remarkably finite number of nucleic acid combinations. While only a handful of these sequences nurture life forms as intricate as humans, the potential configurations to assemble nucleic acids are astonishingly boundless, each arrangement creating the possibility of a life form. The number of possible human beings, a manifestation of this biological creativity, is dramatically greater than the actual number that has inhabited this Earth. This realization opens a panorama of untapped possibilities, suggesting that better, more adept configurations may exist, perhaps life forms that exemplify virtues outpacing our own. Yet, as we stand at the precipice of genetic engineering, faced with the foresight of being able to sequence nucleotides to create tailored characteristics, we must tread carefully. The prospect of designing life, crafting beings with predispositions to thrive or stumble, invokes profound contemplation about the moral and ethical boundaries of such power. Evolution, our ongoing narrative, unfolds through the delicate dance of mutation and selection. Mutations, which can dart into existence during replication, where the DNA polymerase sometimes falters, or through the assaults of cosmic radiation, ultraviolet light and environmental toxins, are the sparks that ignite biological innovation. When the mutation rate finds its balance, life flourishes in elaborate adaptations that reflect survival's demands. And yet, too much deviation from the norm can annihilate the very heritage of our species, a heritage that took billions of years to sculpt. Within this biological script, even a solitary change in the genetic fabric, an alteration of just one nucleotide, can ripple through the body to produce astonishing changes. Consider the human bloodstream, where red blood cell shapes diverge noticeably across genetics, from the biconcave discs of European lineages to the sickle-shaped cells prevalent in parts of Africa. This single mutation bestows resilience against malaria, illustrating nature's duality, a bittersweet acknowledgement that it is often better to face a lesser threat of anemia than the devastating embrace of mortality. The parallels between us and the trees stand testament to a deeper bond, an intimacy unveiled at the molecular level. Yes, we perceive the world through different lenses, yet in our essence, we resonate harmoniously with life itself. Both trees and humans wield nucleic acids for heredity, employing proteins as catalysts to govern the multitude of chemical reactions that fuel our existence. The genetic code we share is a universal script, written by the primordial ink of life, linking us with the myriad organisms that traverse the earth. As we ponder the nature of this unity, the question arises, how did such critical molecules come into being? The answer, tangled within the narrative of evolution, reveals extraordinary insights. While genome blueprints bear remarkable similarities, they are not uniform across all organisms. At times, the translation process for proteins diverges between the nucleus and the mitochondria of a single cell, hinting at an ancient symbiotic relationship where independent life forms merged into the complex tapestry of contemporary cells. In this exploration of life on Earth, each molecule tells a story of creation, adaptation, and transformation. The proteins that govern our biochemistry and the nucleic acids that encode our existence beckon us to uncover the mysteries that underpin our reality. From the infinitesimal reaches of genetic assemblies to the sprawling diversity found today, we find ourselves intertwined with the grand narrative of the cosmos, one voice among many in this cosmic fugue, echoing the potential of existence yet to be realized. As we gaze into the future, we remain acutely aware of the balance between mutation and selection. Each choice made today in our understanding of genetic science holds the promise of new pathways forward, or the peril of unfathomable consequences. In this age of genetic enlightenment, we must honor the delicate balance of evolution and the sanctity of life, contemplating the legacy we wish to create in our shared journey through the universe. Understanding the symphony of life, a journey through prebiotic chemistry. In a realm beyond time, life on Earth is a vibrant tapestry woven from an intricate ballet of proteins and nucleic acids. These molecules are the unsung heroes of cellular chemistry, choreographing the many processes that sustain living organisms. Yet, within this expansive sea of potential, only an exquisitely restrained number of nucleic acid sequences hold the key to genuine life. The evolution of these building blocks over centuries, through various symbiotic relationships, offers profound insights into a critical chapter of our planet's history, the bridge between the primordial genesis of the first cell and the dazzling explosion of multicellular diversity during the Cambrian period. Here, within the hallowed halls of my laboratory at Cornell University, we delve deep into prebiotic organic chemistry. Our mission is akin to composers scribbling the initial notes of life's grand symphony. With curious minds and equipped with cutting-edge tools, we embark upon the exhilarating journey of recreating the conditions of early Earth. In our sparkling glass reaction vessels, we mix primordial gases, hydrogen, water, ammonia, methane, and hydrogen sulfide, an atmospheric concoction remarkably similar to that still swirling on the massive planet Jupiter. Through the flicker of electric sparks, mimicking the bolts of lightning that once danced across an ancient sky, we witness a remarkable transformation. The initially transparent crowd of gases begins its metamorphosis. Brown pigments crawl up the vessel's walls, casting shadows of opaque complexity within. Just 10 minutes into our experiment, the vessel becomes coated in a thick, dark tar, a rich amalgam of complex organic molecules. This transformation serves as a beacon of promise, suggesting that the building blocks of life may not be as elusive as once thought. Such pioneering experiments were first ignited in the early 1950s by a curious graduate student named Stanley Miller, working under the guidance of the esteemed chemist Harold Urey. Urey argued persistently that the nascent atmosphere of Earth was rich in hydrogen, a sentiment echoed throughout the cosmos, where hydrogen remains abundant. He proposed that, as the Earth shed much of its hydrogen to the void of space, the origin of life itself took place before this elemental escape. When challenged about the potential outcomes of sparking these gases, Urey quipped with ambitious hope, Beilstein, referring to the vast compendium cataloging all known organic molecules. Through experimentation, we demonstrate that by harnessing those primal gases, along with any form of energy that shatters chemical bonds, we can craft the essential components of existence. However, it is essential to note that within our glass vessel, we possess only the notes of life's grand composition, disjointed fragments that await proper arrangement. Life embodies far more than mere amino acids or nucleotides. It demands a precise choreography that intricately structures these building blocks into lengthy, functional chains. Our understanding has gained remarkable strides as we mimic the conditions of primordial Earth, successfully synthesizing amino acids into burgeoning protein-like structures. These nascent proteins begin to exhibit faint echoes of biochemical function, engaging in elementary reactions much like enzymes. Moreover, through experimentation, we have painstakingly assembled nucleotides into strands of nucleic acids, albeit only a few dozen units long. The most groundbreaking revelation is that, under the right conditions, these short nucleic acids display an uncanny ability, self-replication. Yet despite our significant advancements, the transition from inert molecules to living organisms remains shrouded in mystery. To date, no scientist has sparked the gases of ancient Earth only to witness a living creature emerge from the confines of a test tube. The simplest living entities we confront today, the viroids, are elegant simplicity defined, comprising fewer than 10,000 atoms. These diminutive beings inflict their will upon cultivated plants, wreaking havoc as parasites, a testament to their evolutionary lineage, suggesting that they have emerged from more complex ancestors rather than from primitive origins. Viroids are a unique curiosity. Unlike viruses, which are enveloped in a protein coat, these entities consist solely of a linear or circular strand of RNA. Their incredibly diminutive nature allows them to survive and thrive, duping larger host cells into converting from conscientious factories of life into relentless producers of viroids. Through this exploration of the cosmos and the genesis of life, we reach a poignant realization: only a remarkably select group of nucleic acid molecules possess the potential to flourish. The symbiosis birthed in the crucible of evolution continues to emerge more sophisticated, constantly whispering hidden secrets about our existence and the expansive universe that cradles us. We remain captivated by the celestial dance of atoms and molecules, eager to decode the music of life itself, and to seek the answers woven into the very fabric of our being. In the grand tapestry of existence, the quest to understand life, its origins, its forms, and its infinite possibilities, has captivated humankind for centuries. The universe, with its myriad of stars and planets, beckons us to ponder what life could thrive beyond our blue planet. But before we jump to these cosmic conclusions, we must first explore the smallest threads of life as they have woven into the fabric of Earth. In the microscopic world, a select few nucleic acid molecules possess the remarkable ability to facilitate the development of life. Among the tiniest living entities are pleuropneumonia-like organisms, PPLO, composed of approximately 50 million atoms. These organisms illustrate a critical point: the simpler forms of life, often existing as parasites or codependents, are mere shadows of more self-reliant beings. They manifest the intricate dance of molecular complexity that has led to the kaleidoscope of life we see today. Yet, the modern world does not afford an easy life to such simple organisms. In the contemporary ecological landscape, thriving necessitates vigilance against predators and a continual struggle for sustenance. But in the dawn of Earth's history, an environment teeming with organic molecules, forged through the relentless light of the sun against a hydrogen-rich atmosphere, provided a fertile ground for the most rudimentary forms of life to flourish. Imagine a primordial soup where free-living viroids, composed of only a few hundred nucleotides, emerged against a backdrop of burgeoning organic compounds, pushing the boundaries of existence. The journey to understand the genesis of life, including the elusive origins of the genetic code, has only recently gained traction, yet we find ourselves embarking on this adventure with a mere 30 years of exploration contrasted with nature's 4 billion-year head start. Remarkably, we have made notable strides on this journey. The exciting aspect of our scientific inquiry is that it is not confined to the confines of Earth. The building blocks of life, the initial gases, and the dynamic energy sources are ubiquitous throughout the cosmos. In laboratory settings, we simulate the chemical reactions that potentially mirror those occurring in the vast expanse of interstellar space and within meteorites, where amino acids have been discovered. It's a tantalizing prospect. The molecular threads that weave the fabric of life may very well connect a billion other worlds, scattered like stars across the Milky Way galaxy. However, we must tread carefully in our expectations. Even if extraterrestrial life shares the same molecular chemistry as life here, it does not inherently mean it will resemble the organisms we know. The diversity displayed by Earth's myriad life forms is astounding, all evolving under the same conditions yet taking radically different paths. Unique solutions to common environmental challenges could lead to convergent evolution, forging creatures with shared characteristics, such as paired eyes for optimal vision. Yet the unpredictable nature of evolution insinuates that extraterrestrial life, if it exists, could diverge significantly from terrestrial species. Envisioning what such lifeforms might appear like challenges the very limits of our imagination. My experiences and understanding of life are fundamentally rooted in the terrestrial experience, and any vision of extraterrestrial beings is inherently shaped by this scope. Various artists and science fiction writers have spun tales of aliens with familiar biological characteristics. How curious they seem to propose life forms with familiar hues, shapes, and even quirks. However, the truth lies in the extraordinary improbability of each species' evolution. Life elsewhere could defy our expectations entirely. Picture, for instance, an enormous gas giant like Jupiter. It offers no solid ground beneath its swirling clouds of hydrogen, helium, methane, and ammonia, a volatile atmosphere rich with organic molecules that could fall like rain, reminiscent of a biblical miracle. Still, the potential of life in such a tumultuous environment is marred by harsh realities. The relentless turbulence and the oppressive heat lurking within its depths pose formidable challenges for any form of existence. To explore this intriguing possibility, my esteemed colleague, E. Salpeter, and I have delved into calculations that assess the viability of such alien worlds. While we cannot definitively predict the forms life might take in such environments, we seek to explore whether the laws of physics and chemistry allow for an inhabited world beneath the cloud-strewn chaos. Furthermore, the credibility of astrologers themselves falters under scrutiny. In controlled studies, these practitioners fail to provide reliable character assessments or future predictions for individuals whose only known trait is their time and place of birth. Skepticism regarding astrology is not a modern phenomenon, nor does it belong exclusively to Western thought. Literary works from as far back as 1332, such as Tsuruzuregisa Kenko's essays on idleness, convey similar sentiments. Kenko critiques the prevalent beliefs surrounding red tongue days, during which people were historically warned against initiating new projects. He notes that attributing failure to such days is nonsensical, positing that failed endeavors initiated on lucky days likely matched those started on unlucky ones in sheer number. Take a moment to ponder the flags that represent nations across our globe. Each flag embodies its nation's ethos, history, and aspirations, yet an intriguing common thread emerges in approximately half of them: astronomical symbols. The United States, with its constellation of 50 stars, the Soviet Union and Israel, representing singular celestial bodies, or China, which proudly displays 5 stars. Australia, New Zealand, and other territories honor the Southern Cross. Nations such as Bhutan showcase the mystical dragon pearl, the embodiment of Earth's power, while Cambodia evokes the grandeur of the Angkor Wat observatories in its design. This celestial representation, transcending cultural and temporal boundaries, weaves a fabric connecting human identity with the cosmos. Our penchant for celestial symbols is not a mere coincidence, it reflects a collective yearning to embrace something greater than ourselves, to find meaning within the vastness of space. Unlike the personal, narrow correlations that astrologers purport, our connection with the cosmos originates in profound and universal themes: the genesis of matter, Earth's capacity to sustain life, and the intricate pathways of human evolution and destiny. The lineage of modern astrology can be traced back to Claudius Ptolemaeus, commonly known as Ptolemy, a figure whose intellect bridged the worlds of science and belief. Although Ptolemy had no familial ties to the Egyptians who bore the same name, his contributions would solidify astrology's presence in Western culture for centuries. In this intricate dance between stars and human experience, we endeavor to discern the legitimacy of astrology, recognizing both its historical allure and its inherent inconsistencies, while seeking knowledge that is, quite possibly, far deeper and more expansive than the constellations that dot our night sky. Our quest for understanding the universe may one day reveal that the myths we embrace serve a purpose of inspiration and connection to something grander, echoing our existential curiosity about life, the cosmos, and our place within it. The harmony of worlds. In an age steeped in wonder and inquiry, the Library of Alexandria stood as a beacon of knowledge, an oasis of thoughts collected from distant lands and various cultures. Within its hallowed halls, scholars and astronomers tirelessly sought to decipher the enigmatic dance of the heavens that arched above them, often interpreting it through the dual lenses of empirical observation and ancient myth. The kaleidoscopic blend of superstition and science intermingled, creating a tapestry woven with dreams, beliefs, and aspirations. Among these intellectual giants was the venerable Claudius Ptolemy, a polymath whose contributions to astronomy would echo through the annals of history. In the 2nd century, during the flourishing reign of Antoninus Caesar, he transformed astrological beliefs into a structured framework rooted in the knowledge of his time. His work, the Tetrabiblos, became the cornerstone of astrology, detailing how the celestial bodies influenced life on Earth. While the stars danced unabated, Ptolemy painstakingly recorded their positions and interpreted their significance. A typical horoscope from his era spoke volumes about the person's character and fate, as seen in the horoscope written in Greek for the little girl named Philo, born in year 150. The birth of Philo. The 10th year of Antoninus Caesar the Lord, Faminoth 15-16, first hour of the night. Sun in Pisces, Jupiter and Mercury in Aries, Saturn in Cancer, Mars in Leo, Venus and the Moon in Aquarius, Horoscopus Capricorn. Though the passage of time has changed how we measure months and years, the astrological principles Ptolemy outlined have remained strangely untouched by the same temporal shifts. He pieced together celestial configurations, arguing that the positions of planets could delineate complex human characteristics. His descriptions of Saturn's influence were vivid and detailed, he claimed. Saturn, if he is in the Orient, makes his subjects in appearance dark-skinned, robust, black-haired, curly-haired, hairy-chested, with eyes of moderate size, of middling stature, and in temperament having an excess of the moist and cold. In Ptolemy's eyes, the stars were the architects of fate, influencing not just personalities, but also complexion, stature, and even congenital anomalies. In the shadow of his brilliance, it was perplexing how modern astrologers cherry-picked aspects of his teachings while disregarding significant shifts in astronomical understanding. The truths gleaned from the cosmos were clouded by a veil of preconceptions, not least of which was a lack of awareness regarding phenomena like the precession of the equinoxes, a concept Ptolemy himself elucidated. He was acutely aware of the atmospheric effects that could distort what the naked eye perceived. Yet in contemporary astrology, many neglect the wealth of celestial bodies discovered since Ptolemy's time, including the asteroids, comets, and the galaxies that explode in scintillating arrays. There lies a chasm between astronomy, the rigorous study of the universe, and astrology, a belief system lacking empirical evidence. In Ptolemy's time, the line separating the two fields was scarcely defined, but today it is a chasm that spans epochs. Astronomy is the language of reason, the seeking of knowledge through observation and fact. Astrology, by contrast, twirls in a world of conjecture, where individual destinies are claimed to be swayed by the capriciousness of celestial bodies. Driven by his insatiable quest for knowledge, Ptolemy took on the role of a pioneer. He catalogued the stars, measured their brightness, and championed the notion of a spherical Earth. His extraordinary insights provided the groundwork for predicting eclipses, but his core endeavor lay in understanding the bewildering motions of planets as they traversed the celestial sphere. He marveled at the spectacle above him, penning his ecstasy in the words. Mortal as I am, I know that I am born for a day. But when I follow at my pleasure the serried multitude of the stars in their circular course, my feet no longer touch the earth. He constructed elaborate models to represent the movements of celestial bodies, using instruments that mimicked auroras, those intricate devices reflecting the solar system's mechanics. Ptolemy was enmeshed in the dominant belief of his era, the Earth as the center of the cosmos. It was a notion so beguiling and seemingly rational given the observable world. The Earth remained steadfast while the stars rose and set like luminous waves upon the shore of night. This geocentric perspective was universally accepted across cultures, resonating deeply within human consciousness, drawing forth a reflection of the very lives they led beneath the heavens. As Johannes Kepler famously articulated, the Earth itself was perceived as a vast dwelling under the sky's grand dome, static while the sun flitted about like a bird in search of food. This metaphor, laden with simplicity, encapsulated the shared mindset of Ptolemy's age, a world where knowledge intertwined with mystery. Yet this stance posed an intriguing question as the ancients gazed at the striking movements of the planets: how to reconcile Mars' peculiar retrograde motion, one that captivated imaginations long before Ptolemy's time. The ancient Egyptians even dubbed Mars Sektaduv Mkeket, a term that poetically rendered, who travels backwards, hinting at its confusing path across the sky. In summation, Ptolemy's legacy is a profound reminder of the delicate interplay between celestial observation and human interpretation. The constellations that once dictated the lives of many now remind us that knowledge evolves. In reflecting on those who sought to understand the harmony of worlds, we forge a path toward deeper comprehension, bridging the gap that once separated superstition from empirical science in the relentless pursuit of truth. The celestial gears crafted by Ptolemy and others continue to turn, urging us to look up in wonder as we explore the cosmic narrative that spans the eons. The harmony of worlds, a new dawn of understanding. In a realm where superstition clouded the brilliance of observation, the study of celestial bodies transformed from rigorous inquiry into a canvas painted by myth and dogma. The luminous library of Alexandria, a beacon of knowledge in the 2nd century, stood as a testament to this tangled history. Within its grand halls, scholars wrestled with the mysteries of the universe, desperate to decode the real motions of the planets as perceived from the vast expanses of space compared to their earthly orbits. For centuries prior, in a swirl of ingenuity, Archimedes conceived an ingenious contraption that captured the essence of these cosmic movements. This mesmerizing device caught the eye of Cicero during his time in Rome, as it journeyed alongside the Roman general Marcellus, carrying with it echoes of an earlier, brilliant mind. Unfortunately, this era of enlightenment was stained by violence. Archimedes met his untimely demise in Syracuse, his brilliance extinguished at the hands of a soldier acting against orders. Such was the tragedy of a world where knowledge could be silenced so abruptly. The celestial spheres that cradled the planets were envisioned as perfect, transparent orbs, distinct yet intricately entwined. Instead of being directly attached to these spheres, the planets were linked through an off-center wheel, an innovation designed to imitate the graceful dance of Mars as it performed its mesmerizing loop-the-loop in the night sky. This Ptolemaic model produced sufficiently accurate predictions of planetary motion, a feat satisfactory given the primitive tools of measurement accessible during Ptolemy's era and extending into the eons beyond. Medieval thinkers, enamored by Ptolemy's ethereal spheres crafted from crystal, sparked a lingering fascination with the celestial melodies of the music of the spheres, and the concept of a seventh heaven. In this worldview, Earth rested at the center of the cosmos, bearing the weight of creation's pivot. With divine forces constructed on alien principles, the motivation for rigorous astronomical inquiry waned, dulled by the Church's grip during the Dark Ages. Ptolemy's influence solidified dogma, effectively stifling advancements in astronomy for a millennium, a sentiment that would soon face upheaval. The story took a revolutionary turn in 1543 when a Polish Catholic cleric named Nicholas Copernicus dared to unveil a radical hypothesis. He declared that it was not the Earth but the Sun that occupied the center of the universe, relegating our planet to the third position in a cosmic hierarchy where it orbited in circles as perfect as the dreams of mathematicians. Ptolemy himself had flirted with the notion of a heliocentric model but recoiled at its implications, swayed by Aristotelian physics which suggested that an Earth in motion would contradict observable stillness. Copernicus's model performed at least as well as its predecessor in decoding the movements of the heavens, yet it unwittingly strummed the chords of dissent. In 1616, the Catholic Church branded his work as forbidden, demanding its correction by ecclesiastical enforcers, a ban that would endure until 1835. The fervent words of Martin Luther echoed in the chambers of opposition, condemning Copernicus as an upstart astrologer, and a fool who endeavored to upend the very foundations of astronomy itself, misguidedly anchoring his argument to a scriptural tale of Joshua halting the sun rather than a more profound truth. Even among Copernicus's circle, debates raged on the sincerity of his convictions. Some suggested that he merely offered the heliocentric model as a computational convenience rather than a genuine belief in the sun's supremacy. Yet, the shadows of censorship loomed large. A thorough inventory conducted by Owen Gingerich revealed that only 60% of 16th-century editions of Copernicus's seminal work in Italy had been corrected, while in Iberia, not a single copy bore the mark of ecclesiastical alteration. Thus unfolded an epical confrontation between the entrenched Earth-centered cosmology and the audacious sun-centered paradigm, culminating in a cacophony of ideas and realizations during the 16th and 17th centuries. A man emerged from this tumult, straddling the roles of astronomer and astrologer, a figure ensnared in a time of intellectual shackles and fear. The ecclesiastical decrees of centuries past held greater allegiance than the provocative inquiries of the modern era, where innovative examination and newly concocted techniques were deemed untrustworthy compared to ancient beliefs. As the dialogue between superstition and empirical inquiry grew increasingly tangled, a rich tapestry of thought and expression began to weave the fabric of the cosmos, paving the way for a more profound understanding. The challenge lay not just in deciphering celestial mechanics but in liberating the human spirit from the chains of dogma, and as history marched onward, the harmony of worlds seemed closer to discovery, waiting to unfurl like the petals of a long-dormant flower in the sun's embrace. Thus, with each new realization, humankind inched closer to unraveling the enduring enigma of the universe, sowing seeds of curiosity that would flourish long into the stars. In the ancient fabric of human understanding, where superstition wove its threads intricately with the fledgling strands of science, we find a rich tapestry of thought, belief, and inquiry. At the heart of this exploration lies the Library of Alexandria, a beacon of knowledge in the 2nd century, where scholars first sought to bridge the chasm between the mystical and excavate ideas from the depths. One group put one hollow to use while another group constructed another hollow. He found himself amidst the rich discourse of belief and knowledge that spanned time and tradition. Yet, there was a dissonance within him. He pondered the age-old doctrine that loomed over every gathering, that of the Trinity. From his early studies and the volumes of ancient texts, he sensed that the conventional Christian understanding of this doctrine was a misreading of Scripture, a revelation he would hardly voice. A flicker of influence from his biographer, John Maynard Keynes, whispered to him that he was aligned more closely with the Judaic monotheism embraced by Maimonides, a school that echoed the singular focus of the divine. This conclusion emerged not from mere rational or skeptical grounds, but through a deep interpretative reading of ancient authority. The revealed documents, he believed, offered no sanctuary for Trinitarian doctrines that appeared to be later fabrications sewn into the fabric of faith. But the notion of one God was a dreadful secret for Isaac, one he felt compelled to conceal. For amidst the clamor of theological debate, the idol of multiplicity overshadowed the truth he grasped. A silent burden replaced his youthful exuberance, the air around him grew heavy with the gravity of conviction. Isaac, like his predecessor Johannes Kepler, was not immune to the superstitions and mystics of his time. A strange dialectic loomed between rationalism and the allure of the unknown, creating a fertile ground for intellectual growth. At the exuberant Stourbridge Fair in 1663, at the tender age of 20, an impulse guided his hand to purchase a book on astrology. What he sought in those pages was clarity, yet what he found instead was a riddle, a drawing he could not comprehend because he was yet unversed in the language of trigonometry. Yet, this curiosity ignited a cascade. He sought further knowledge and procured a tome on trigonometry, only to be ensnared in its complexities. Determined, Isaac discovered a copy of Euclid's Elements of Geometry, and thus began a transformative journey. He dove deep into the world of shapes, angles, and proofs, transcending the boundaries of what was known. It was within 2 short years that he birthed a revolutionary idea, the differential calculus, a language of change and motion that would echo through the annals of science for centuries. His fascination, however, was not merely confined to the abstracts of mathematics. He was entranced by the majesty of light and the brilliance of the sun. A reckless endeavor led him to stare at the sun's reflection through a looking-glass, a dance with danger that left his eyes tormented. In a few hours, he recalled, I had brought my eyes to such a pass that I could look upon no bright object with either eye. Fearful of a lifetime of blindness, he locked himself away in a dark chamber, wrestling with his thoughts on light and what it meant to perceive in darkness. For if he let his mind wander, even within shadows, he would see the sun's blinding image chasing him. The year 1666 marked a critical juncture in Isaac's life. A deadly plague swept across Cambridge, forcing the young scholar to retreat to the remote village of Woolsthorpe, the very place of his birth. In the isolation of rural life, away from the structured halls of academia, Isaac experienced a profound blossoming of ingenuity. He delved deep into introspection and experimentation. This solitary confinement became a cradle of discovery. It was there that he invented both the differential and integral calculus, unveiled the secrets of light, and stitched the first threads of the theory of universal gravitation. He felt no need for grand explanations when questioned about his extraordinary feats. By thinking upon them, he would simply say, leaving those around him to wonder in admiration. The brilliance of his insight was so profound that Isaac Barrow, his esteemed mentor at Cambridge, resigned his position to clear the path for the gifted student, 5 years after Isaac's return to the college. In his mid-40s, Isaac had long since surrendered to the rigorous demands of intellectual life. A servant remarked on his relentless pursuit of knowledge, stating, I never knew him to take any recreation or pastime, thinking all hours lost that were not spent in his studies. For him, time was a cruel mistress, and he felt each moment wasted unless ensconced in thought and inquiry. He rarely emerged from his chamber except during lectures, where those few who gathered often struggled to grasp the depths of his teachings. Many times, he found himself reading to the barren walls, his voice reverberating among the empty shadows. The students of Kepler and Newton lived in worlds defined by the wisdom of their mentors, but few understood the depths of what they offered. Those who studied Newton learned of inertia, the notion that a moving body will persist in its trajectory unless influenced by an external force. He marveled at the moon's celestial dance, recognizing that it would fly off into the void if not for the unseen tether, a force he named gravity, which he theorized acted across distances unfathomable. The bond between the Earth and its moon was enigmatic. Nothing physically linked the two, yet a force persistently pulled the moon toward Earth, embodying the essence of attraction. In the midst of his discoveries, Isaac navigated the labyrinth of thought, ever aware of the myriad secrets held by the universe. He continued to wrestle with his own beliefs, seeking to harmonize the apparent divisions within faith and reason, a delicate balance like the orbits that govern celestial bodies around him. And thus, as he strode boldly into the realms of science and philosophy, he always sought to filter knowledge through the lens of inquiry. I want to be on the side of the many, he reflected, ever determined to share the wonders he discovered in the universe of minds and stars, illuminating the shadows with the torch of understanding. The same harmony that guided the celestial world also whispered to humanity through eons and traditions. And in this delicate dance of faith and knowledge, the true quest unfolded, a search for the oneness that knit together all of creation. In the endless dance of celestial bodies, amidst the whispers of time and the fabric of the universe, Isaac Newton stood poised like a solitary lighthouse illuminating the dark waters of ignorance. He yearned to champion the many, those who questioned, who were curious, and who, like him, sought to unearth the secrets of the cosmos. While different minds constructed intricate theories about the nature of existence, Newton encapsulated the essence of the universe's workings into mathematical expressions, discovering how one hollow could sustain another in perpetual harmony. Newton's explorations began with the seemingly mundane, an apple falling from a tree, its descent dictated by an unseen force. Little did he know that this simple observation would unravel the fundamental nature of a gravitational force that governed the very dance of the moon around the Earth around the Sun, and even the recent discoveries of Jupiter's moons in their majestic orbits. This revelation was monumental, yet echoed with an uncredited debt to the celestial insights of Johannes Kepler. Though the grand compass of his work, the Principia, carved a new path in scientific thought, it overlooked Kepler's earlier revelations about the orbits of planets, leading Newton to later write to his friend Edmund Halley, "I can affirm that I gathered it from Kepler's theorem about 20 years ago." From epochs long gone, humanity had stared at the heavens, captivated by the unyielding motion of the moon, believing it a celestial guardian of Earth. For the first time, Newton illuminated that the force pulling the apple down to the Earth was kin to the force that danced the moon in its orbit. Reveling in the wonder of his discovery, Newton declared this insight as the law of universal gravitation, a truth woven into the very fabric of existence, applicable everywhere in the vast cosmos. But gravity, as Newton posited, held a paradoxical nature, governed by the law of the inverse square. As two objects drifted farther apart, the gravity binding them diminished significantly. Pulling them apart just twice the distance made the gravitational attraction merely 1/4 strong. Imagine a universe where the laws were direct rather than inverse, where distant stars would clump into an accidental cosmic heap. Newton championed an idea where gravity diminished with distance, a notion that elegantly explained why comets and planets danced in their orbits, moving slowly at the periphery of the sun's embrace, only to hasten as they drew closer. Newton synthesized Kepler's empirical laws of planetary motion into a single theoretical framework that proudly proclaimed, "I now demonstrate the frame of the system of the world." By distilling the painstaking observations of Tycho Brahe into a cohesive mathematical model, he granted humanity the tools to predict the movements of celestial bodies, setting the stage for generations of scientific inquiry. As the years folded into decades, Newton's life began to mirror the complexities of the universe he had uncovered. Burdened by presiding over the Royal Society and managing the Mint's strenuous battle against counterfeit coinage, he grew reclusive, retreating from the quarrels that often erupted with his scientific contemporaries. Some whispered of an inner turmoil, thick as the mysteries of the heavens, suggesting a breakdown akin to what would be recognized today as a mental health crisis. Yet, modern investigations hinted at the real culprit being the heavy metal poisoning from the long-standing alchemical practices of his time, where arsenic and mercury were used for experimentation. Perhaps, in those alchemical flames, Newton's mind remained unscathed, burning bright amidst the shadows of uncertainty. In a fateful twist of celestial drama, 1696 ushered in the brachistochrone problem, a conundrum posed by the brilliant Johann Bernoulli. He challenged mathematicians to find the curve that would allow a body to fall between 2 points in the swiftest time, a challenge that would ignite the fires of rivalry and ingenuity among the greatest intellectuals of the era. Initially setting a deadline of 6 months, Bernoulli exhibited patience, extending it to 1.5 years at the behest of the enigmatic Gottfried Leibniz. On January 29, 1697, as the clock struck 4, the challenge was inscribed into the annals of history, a testament to Newton's restless mind. Thus, within the heart of this unfolding narrative lay the essence of a universe bound by both wonder and inquiry. Newton's reflections on gravity began with a simple desire, to stand with the multitude, supported by the many layers of knowledge through which mankind could peer at the cosmos' grand design. And in recognizing that the divine geometry of mathematics reshaped a world once ruled by mere observation, he not only uncovered the gravitational force but ignited a revolution, a shift in our collective understanding of the universe that echoed into eternity, forever altering the harmony of worlds. Once upon a time in the rich tapestry of the early modern world, a brilliant mind grappled with the mysteries of existence. In the heart of this endeavor lay a man named Isaac Newton, a towering figure whose insights would reshape the very fabric of scientific thought. Early in his exploration, Newton conceived an extraordinary connection between the mathematical elegance of the conventional Christian belief in the Trinity and the profound nature of gravitational force. It was a startling moment of clarity, where faith intertwined with reason. The following morning, as the dawn crept in with the promise of new discoveries, he birthed an entirely new branch of mathematics, the calculus of variations. This innovative framework would allow him to navigate complex problems that had flummoxed mathematicians before him. Among these was the brachistochrone problem, a conundrum concerning the trajectory of a bead sliding between 2 points, seeking the shortest time of descent. With a deft hand, he crafted the solution and, wishing to remain modest, submitted it anonymously at the behest of his respected contemporary, Sir Isaac Newton. Yet talent cannot remain hidden for long. The brilliance and originality of this mathematical solution soon unraveled the mystery of its author. The renowned mathematician Johann Bernoulli, upon encountering the elegant resolution to the problem, famously remarked, "We recognize the lion by his claw." It was a testament to Newton's undeniable mark on the literary and scientific world, despite his desire for anonymity. As the years passed, Isaac Newton, now 55, turned his keen intellect towards new horizons. His last intellectual pursuit became a labor of love, a vast concordance and calibration of ancient civilizations' chronologies. Drawing inspiration from the great historians of antiquity, Manetho, Strabo, and Eratosthenes, Newton endeavored to weave a cohesive understanding of humanity's past. In his final, posthumous work, The Chronology of Ancient Kingdoms Amended, he laid forth detailed astronomical calibrations of historical events, reconstructed the majestic Temple of Solomon, and provocatively suggested that the Northern Hemisphere constellations were named in homage to the characters, artifacts, and tales of Jason and the Argonauts. Further, Newton ventured into a realm of bold speculation. He asserted with conviction that the gods revered in various civilizations, with the singular exception of his own belief system, were simply ancient kings and heroes whose legacies had been deified by grateful descendants. This reflection showcased his deep understanding of the interplay between history and mythology, a testament to his expansive mind. Alongside Johannes Kepler, Newton marked a pivotal transition in human history. Together, they revealed that the cosmos operates under a tapestry of simple mathematical laws. These laws were implausible. The most plausible explanation is that impacts occur at similar frequencies on both the Earth and the Moon. However, the Moon's lifeless environment allows craters to endure throughout millennia, preserved as historical time capsules. In contrast, Earth's surface, obscured by the relentless forces of nature, rushing water, shifting sands, and the ever-mounting processes of geological upheaval, erases these cosmic signatures over geological time. Thus, even the most significant impact scars are sculpted away, vanishing into the mythos of history. Amongst the drifting comets and the solemn history of our celestial siblings, it becomes clear that the Moon not only bears witness to events past but echoes back a complex narrative of existence itself. Each crater tells a story, and each ray is a reminder that the cosmos is not remote, it is, indeed, profoundly connected to our own existence. As the clouds of time roll on, we remain ever-curious adventurers in this grand celestial saga. And perhaps, just perhaps, the tales spun by the Moon and the wanderers who circle it will ignite the flame of understanding that achievements in time and space so richly deserve. Heaven and Hell, a cosmic exploration. High above, veiled in a luminous cloud, a collection of comets dances around the celestial sphere, their paths stretching into highly elliptical orbits as they plunge toward the sun. These celestial travelers, much like the Moon, testify to phenomena that echo stories long whispered by ancient scribes and monks, such as those from Canterbury. They are silent witnesses to the grandeur and chaos of the cosmos. On the surfaces of moons and planets, we find a confluence of external and internal processes shaping their very being. External forces, like meteoric impacts from the abyss of space, intertwine with the internal currents of upheaval, represented by earthquakes that send ripples through a planet's crust. There are spectacular, lightning-fast volcanic eruptions that can alter landscapes in an instant, contrasting sharply with the gradual, almost imperceptible pitting of surfaces by relentless airborne sand grains, a testament to the passage of time. The question of which processes reign supreme remains unresolved. Do the colossal, outside events hold sway, or do the slow, internal changes narrate the true story of planetary evolution? Take, for example, our Moon. Its surface tells a tale dominated by external cataclysms, evidenced by its crater-filled visage. In contrast, Earth is shaped primarily by the quieter, unrelenting forces of geological activity that go unnoticed but quietly sculpt the land. Mars occupies a unique position, serving as an intermediary in this cosmic ballet of forces. Its surface bears evidence of both, hinting at a history of explosive impacts coupled with the slow adjustments of its former geology. Beyond Mars and between the vast orbits of Mars and Jupiter lies a veritable treasure trove known as the asteroid belt, home to countless asteroids, tiny terrestrial planets in their own right. The largest among them stretch hundreds of kilometers across, their oblong shapes tumbling through the great expanse of the cosmos. Many asteroids revolve in tight formations, communicating with each other through gravity, while collisions among them are frequent and often violent. Occasionally, fragments are released from these ancient bodies, sent hurtling toward Earth, where they impact our planet, falling as meteorites to the ground. Within our museums lie the remnants of these celestial wanderers, fragile relics whispering tales of distant worlds and forgotten epochs. The asteroid belt itself operates as a vast cosmic grinding mill, eroding larger bodies down to mere motes of dust. But why does this debris exist? It represents either a region where the icy fingers of gravity from Jupiter prevented a planet from forming, or the fragmented remains of a once whole planet that met a violent end. Such a fate seems improbable, for earthly knowledge is limited. No one can definitively attest to how a planet may shatter into oblivion. Towards the edge of this cosmic tableau, the rings of Saturn present a striking parallel to the asteroid belt, a constellation of tiny icy moonlets orbiting in a majestic display. These fragments may embody the debris that could not coalesce into a nearby moon due to Saturn's overwhelming gravitational might. Alternatively, they could be remnants of a moon that strayed too near and succumbed to the immense pull of its parent planet. The rings might also reflect a state of balance, caught between material expelled from moons like Titan and particles spiraling into the atmosphere of Saturn itself. Yet, the intrigue of cosmic structures does not end there. Recently discovered, the faint and elusive rings of Jupiter and Uranus remind us that the adornment of rings may be a common feature among Jovian-type planets throughout the vast tapestry of the universe. The question of whether Neptune possesses a ring system remains tantalizingly unresolved, ensuring these celestial bodies hold on to their secrets. In the backdrop, a controversial narrative took shape in the mid-20th century, the theory posited by Immanuel Velikovsky in his thought-provoking book, Worlds in Collision. Velikovsky's audacious claims suggested that a massive comet, born from the tumultuous realms of the Jupiter system, spiraled into our inner solar system around 3,500 years ago. In his dramatic retelling, this comet collided with Earth and Mars, purportedly parting the Red Sea and elucidating the biblical tale of Moses. He claimed the comet's chaotic dance altered the very rotation of Earth at Joshua's command and incited volcanic activity and catastrophic floods. Before Velikovsky, Edmund Halley made the first non-mystical connection of historical events with comets, suggesting that the Noachic flood might have been ignited by the shock of a passing comet. Yet, it is essential to acknowledge that broader scientific consensus remains skeptical of these recent collision theories. While astronomers do not disregard the possibility of major collisions shaping our universe, they contest the assertion of such cosmic drama happening in our recent past. In any depiction of the solar system's history, it is futile to resolve the sizes of planetary bodies definitively. So, as we peer into this vast abyss, we behold the cosmic playground, swirling with fragments and forces, each a discovery, revealing a Martian landscape dotted with craters, barren plains, and an atmosphere far too thin to harbor life as we know it. Yet, for all our scientific advancements, Mars' mysteries remain tantalizingly elusive. The landscapes tell a tale of isolation, but in their stark beauty echoes the pursuit of knowledge that resonates across the cosmos. It seems fitting, then, that amidst our endeavors, we still peer into the depths with the same wonder that fueled Lowell's imaginings. We seek not just to understand, but to find connection, to explore the narratives spun across the fabric of the cosmos, much like the hidden life within a drop of water under a microscope. In our quest to comprehend the enigmas of Mars, we remain, above all else, storytellers and dreamers. And in the luminous silence of the night, when we gaze up at the stars, the question lingers, might the echoes of longing and exploration, so deeply ingrained in the human spirit, finally bridge the gap between our worlds? For in that serene quietude of the air, perhaps we find the remedy to our ceaseless quest, perhaps, like Lowell, we can conjure visions of the impossible and spin them into the very fabric of our understanding. Chapter 5, Blues for a Red Planet. In the dim light of his observatory, Percival Lowell meticulously documented his observations of Mars, capturing with fervent passion what he believed were the intricate canals of the red planet. To him, there was an unmistakable order to these features, a semblance of intelligence that hinted at the possibility of life. The early 20th century landscape of astronomy was rugged, characterized by an interplay of hopeful speculation and scientific skepticism. Lowell, with his 24-inch refracting telescope, was a gladiator in this arena, fighting against the winds of doubt that swirled around him. The legendary belief in Martian canals was nurtured by the artistic imagination of humanity, mixed with a burgeoning desire to find life beyond Earth. 20 years after Lowell's assertions, the world was still enthralled by his visions, even as other astronomers, armed with sharper instruments, struggled to find any conclusive evidence of the structures he fervently insisted existed. Sited amidst the bustling city of Boston, Lowell's observatory became a crucible of ideas, where dreams of extraterrestrial life danced tantalizingly on the cusp of reality, but always just beyond reach. Yet, as we delve deeper into the heart of Lowell's notebooks, each page reveals a man grappling more with conviction than certainty. On January 21, 1905, staying true to his patterns of hopeful observation, Lowell penned an entry reflecting on double canals that appeared in bursts, a flicker of detail during moments of clarity. Each observation was a thread weaving together a tapestry of imagination and belief, yet each also echoed in whispers of uncertainty. Was there a flaw in his seeing, or was it the very act of observation itself that conjured illusions? This question haunted my colleague, Paul Fox of Cornell, and me as we embarked on a mission of our own comparisons, bridging the realms of past observations and modern scientific inquiry. Using the Mariner 9 orbital imagery, technology brought forth a sublime clarity, revealing the Martian surface in resolutions that were 1,000 times more detailed than Lowell's tributes to the red planet. As we sifted through the mountainous data, we found an unsettling truth: there was little correlation between Lowell's maps and the intricate visage revealed by spacecraft. Gone were the supposed canals, their locations displaced by the Mars of reality. How could it be that diligent observations yielded such disparate results? Was it a collective but erroneous imagination that had strung together a semblance of order amidst a chaotic landscape? The universe had so often seemed to trick us into believing in the extraordinary based on fleeting glimpses, an echo of infusoria, emerging only under the microscope's careful gaze. However, insight did emerge from these reflections. The streaks and splotches bestowed by time on Mars's surface were merely the dances of dust caught by seasonal winds, shifting and changing, rather than steadfast structures like Lowell's justly famed canals. Gone were the supposed features that could have inspired generations, replaced instead with the transient echoes of a dynamic Martian environment. The prospect of intelligent life on Mars might have blindsided Lowell, but the enigma of his artistic regression into the depths of improbability offered a more human lesson: it was in our nature to conjure narratives where none existed. One had to wonder about the intelligence that rested on either side of the telescope's lens. For as much as Lowell believed he was witnessing the handiwork of a higher intelligence, it was entirely possible that human perception held the greater responsibility for the creations of the mind. As the decades unfolded, the Martian imagination diversified. The fantastical beings imagined by Lowell were transformed over the years into malevolent Martians painted vividly by H. G. Wells in his seminal narrative, The War of the Worlds. Readers flanked both narratives, encapsulated by mythos that drove fantastical explorations and terrifying invasions in their minds. Yet amidst this evolving mythology, there remained a semblance of charm in the visions inspired by writers like Edgar Rice Burroughs. My own childhood bristled with excitement as I turned pages that took me to Barsoom, navigating the winding realities of a Martian existence alongside heroic figures like John Carter, who beckoned forth the wonder of a civilization seemingly lost to time. I dreamt of the blue skies above crimson deserts, where herds of Thoats grazed peacefully and myths came alive. Ultimately, the allure of Mars lies not solely in its surface or the variances of perception that have imprinted themselves onto the human psyche but within the boundless possibilities of imagination itself, the forge that has crafted countless narratives, hopes, and fears for generations. Perhaps it is possible that, like infusoria under the microscope, our understanding of the cosmos can shift and change based upon the clarity of the lens we employ. So, in the faint glow of another evening, we must continue to seek that most serene and quiet air, one that offers not merely a view but allows a profound understanding that transcends past illusions of grandeur. Indeed, Mars holds secrets still, waiting to be unveiled by the eyes of the curious and the brave. Journey to the Kingdom of Helium, a voyage beyond the veil of reality. Underneath the glass of a microscope, the tiny infusoria dance as if caught in a symphony of unseen forces. To the untrained eye, they are merely specks of life, existing in a universe so different yet so similar to our own. Such is the nature of exploration. We seek to understand, to connect, and perhaps to transcend the boundaries of our reality. In moments of serene contemplation, as the quiet air surrounds us, we ponder the same mysteries that have captivated the hearts of dreamers for centuries. Might it truly be possible, in fact and not whimsy, to accompany the legendary John Carter into the Kingdom of Helium on Mars? As the summer sun sets and casts a golden hue upon the horizon, we can visualize ourselves stepping into a world illuminated by the two moons of Barsoom, ready for an adventure of breathtaking scientific discovery. Even if every conclusion drawn by Percival Lowell about Mars, especially his famous theory of canals, was eventually unraveled and deemed incorrect, the impact of his dreams remains undeniable. His vivid tales ignited a spark in the imaginations of countless souls, myself among them. They inspired young minds to believe in the tangible reality of interplanetary travel, to wonder if we could one day traverse the expanse of the cosmos and set foot on the fabled surface of Mars. I recall my boyhood days spent in empty fields, arms outstretched towards the stars, fervently wishing for transport to the red planet. Alas, such wishes yield no results. There has to be a more scientific approach. As life forms evolve, so too do our creations. The journey of the rocket parallels that of living organisms, beginning with humble origins in ancient China, where gunpowder was utilized creating captivating visuals for ceremonies. Fast forward to the 14th century, and this invention transformed into a tool of war, and eventually morphed again as visionary thinkers like Konstantin Tsiolkovsky envisaged its potential for space travel. Tsiolkovsky's musings were picked up by pioneers like Robert Goddard, who transformed theoretical wonders into practical reality. The militaristic applications of rocketry paved the way for extraordinary achievements. The German V-2 rocket made history during World War II, embodying the culmination of innovations brought forth by Goddard. Fast forward to 1948, as the two-stage V-2/WAC corporal combination reached new heights, literally, soaring to an altitude of 400 kilometers. By the late 1950s, visionaries such as Sergei Korolev in the Soviet Union and Wernher von Braun in the United States pushed humanity's ambitions further, culminating in the launch of artificial satellites, a clear indication that our gaze had shifted to the stars. Years flew by as we stood on the shoulders of giants, inches away from understanding our celestial neighbors. Dreams of orbiting scientific stations and probes to discover life on Mars, first conjured by Tsiolkovsky and Goddard, now reside in our reality. We have repeatedly shattered the barriers that once seemed insurmountable with each rocket launched, each satellite sent into orbit, each step taken onto lunar soil. Now, let us engage in an exercise of imagination. Picture yourself as a visitor from a distant star cluster, traversing the galaxies toward a little blue planet, Earth. As you approach, your perspective transforms, allowing you to discern its features, gradually unveiling the tapestry woven by its inhabitants. But when does your judgment shift? At what resolution can you ascertain whether Earth hosts intelligent beings? Initially, from tens of thousands of kilometers above, the great expanses are strikingly barren. Landmarks call out like whispers across the black void, yet in these early moments, they remain unrecognizable. No signs of human artistry scar an otherwise pristine world. Cities like Washington, New York, or Tokyo appear as lifeless silhouettes, devoid of culture, expression, or civilization itself. But as you glide closer, your observational prowess sharpens. The details come alive. The intricate patterns of squares and rectangles emerge with startling clarity. Roads unfurl like ribbons, drawing lines across the landscape, connecting the scattered thoughts of civilization. Highways radiate outward, a testament to mankind's ingenuity and ambition, detailed now at a resolution of a mere 100 meters. The once barren facade of Earth now blossoms with the engineering marvels born from the minds of its intelligent stewards. In this evolving kaleidoscope of reality and aspiration, we reflect on what it means to be explorers, voyagers keen on embracing the cosmos. An adventure awaits, the untamed kingdom of helium beckons. Though the ways to reach Mars remain grounded in technology and science, the fervor captured in the dreams of a child, arms outstretched, yearning for the stars, stays the same. And so, with our spirits ignited by the possibility of other worlds and the endless expanse of space, we continue, ever hopeful, in our quest for understanding beyond the horizon of imagination. Blues for a Red Planet, a journey of discovery. In the vast expanse of the cosmos, we find ourselves drawn to the mysteries of our neighboring planet, Mars. Far more detailed than any view that the astronomer Percival Lowell could have glimpsed through his telescope in the early 20th century, modern technology allows us to delve deep into the red planet's surface, the very essence of possibility and imagination. Might it truly be possible, in fact and not mere fantasy, to venture alongside John Carter into Martian canals and lush farmland, traversing city streets etched into the Martian landscape? What if we could identify patterns that reflect our own twin human passions for Euclidean geometry and territoriality? At a scale no more significant than that which permits us to observe intelligent life on Earth in places like Boston, Washington, and New York, we begin to uncover the narrative of an industrious species. Satellite images, taken in broad daylight, reveal a breathtaking panorama, the surface intricately reworked by the hands of humanity on Earth. Yet, as day turns to twilight and eventually night, additional luminescent narratives emerge. The flickering oil well fires in Libya and the Persian Gulf, the otherworldly glow of the Japanese squid fishing fleet illuminating the deep waters, and the vibrant tapestry of light emitted by bustling cities. Imagine enhancing our resolution to discern individual organisms, whales swimming gracefully through existence. As I ponder this, it's fascinating to contemplate my own composition. I am a collection of water, calcium, and organic molecules, wrapped in the labels and stories that define me, Carl Sagan. You, too, are a collection, possessing similar molecules, yet labeled differently by the narrative of your own life. This line of thought invites a philosophical musing. Is our essence merely the atoms that constitute us? While some insist that reducing the beauty of humanity to chemical elements detracts from our dignity, I find a certain elevation in recognizing that our universe has spun out such intricate assemblies of molecular machines, us. To understand life better, we must delve deeper than just its external components. Doctors and chemists occasionally jest that the value of a human body, stripped of its complexity, may amount to merely 97 cents or $10, approached with a chuckle among the scientific faculties. Such simplification is disheartening, yet it speaks to a profound truth: we are composed largely of inexpensive substances. Water, vital to our very being, costs almost nothing, carbon is common as coal, calcium rests in our bones like chalk, nitrogen floats freely in the air, and the iron within our blood is akin to that found in rusty nails. Were we to gather every atom that makes us up, stirring them together in a grand cosmic blender, we would likely produce nothing more than an indistinguishable sack of soda cans. The essence of our humanity is not in the raw materials but in the elegance of their assembly and the astonishing story they tell together. Harold Morowitz playfully estimated that gathering the correct molecular constituents to recreate a human being would cost around $10 million. Although this figure provides a humorous sense of worth, it only serves to reflect our current limitations. We cannot mix these atoms and expect life to magically emerge from the jar. The creation of a human is still a riddle that eludes our grasp, a masterwork of subtlety, formed over eons. When we turn our gaze to distant worlds, the possibilities thrum with excitement. As I speculate on the diverse lifeforms that may thrive on planets across the cosmos, I envision being formed from similar atoms, elements we know well, like proteins and nucleic acids, but arranged in unique patterns entirely foreign to us. Could a creature floating in thick atmospheres resemble us in atomic makeup yet lack bones, not needing the calcium that strengthens our own frame? Perhaps other, stranger solvents, far removed from water, could be the lifeblood of these beings. Imagine life thriving in hydrofluoric acid, where ordinary carbon-based structures may find swift dissolution, yet resilient organic molecules like paraffin wax might flourish. Or consider environments where ammonia reigns supreme, existing in liquid form on colder worlds, those distant, frozen orbs where life may yet awaken. Yet, despite our imaginative endeavors, we must tether our constructs to the earthly realities reflected in the Viking lander's findings. As it probed the surface, gathering data from the red soil, the results pointed toward a planet that, like our own, houses the essential ingredients for life, carbon, water, but with scant evidence supporting its presence. Image after image revealed no signs of life hidden within the fine particles of Christ and utopia. Here, at the cusp of discovery, we teeter on the brink of understanding, contemplating whether life may linger subterranean, perhaps millimeters beneath the surface, in locations that align with the subsurface lakes of the Antarctic dry valleys, or existing in ages of a warmer Martian past. Ultimately, as we consider the grand tapestry of existence, interweaving the threads of chemistry, biology, and the search for meaning, it raises a final question: could the clay we are fundamentally composed of also connect us to challenging, uncharted worlds? Somewhere in the vast cosmic expanse, perhaps thoughts like mine have a resonance that dances across the stars, perhaps somewhere, beings crafted from the same elements sing a similar song of wonder, pondering their own existence in relation to the cosmos, just as we do. Blues for a red planet, the quest for Martian discoveries. In the distant reaches of our solar system lies Mars, a planet clothed in its own redness, yet eternally craving the touch of discovery. The Viking lander, a mechanical envoy, once touched its surface, speaking in data streams and images, whispering secrets of windblown clays that hinted at the planet's dynamic history. It was a revelation that sent reverberations across the scientific communities of Earth. Could these clays bear witness to the same building blocks of life found here? Would they offer clues to our origins? The Viking mission was indeed a turning point, marking the first serious foray into the unknown realms of extraterrestrial biology. No longer were these realms the realm of science fiction. Viking 1's endurance, surviving on Martian soil for years, transcended what humanity had imagined about life beyond our blue planet. The probe became a vessel of knowledge that poured forth rich insights into the geology, meteorology, mineralogy, and even the potential for life on another world. As scientists stood atop the tower of this newfound knowledge, a question buzzed through the air like electricity: how could we follow up on these spectacular advances? Discussions ignited like fiery comets. Some proposed ambitious plans to deploy sophisticated automata, machines that could descend upon the Martian soil, scoop samples, and return them to Earth. This new breed of mission would allow for deep examinations in the lavish laboratories of Earth, where scientists could unravel the intricate fabric of Martian soil beyond what any microminiaturized Martian lab could achieve. But with such ambition emerged a specter of risk. The echo of public health hazards resonated within the community. If we sought unsterilized Martian samples, could we afford to gamble on the unknown microorganisms they might harbor? The tale of H.G. Wells's extraterrestrial invaders retold a cautionary myth. What if Earth's defenses proved inadequate against Martian organisms? Ensuring our safety became essential, necessitating containment procedures that inspired both awe and trepidation. We could be the architects of our own downfall, pondered Dr. Marie Chen, a leading astrobiologist, during a convention discussing the mission. The proposal carries significant risks if we fail to implement absolute safety protocols. Her voice hung in the air, stirring imaginations while planting seeds of unease. Could Martians, if they exist at all, prove benign? Or would they descend upon our world uninvited? The magnitude of these questions loomed, taller than Olympus Mons itself. Yet another wave of potential beckoned from the dusty landscape of Mars. The Viking images, rather than just raw data, stimulated a longing for exploration. The unyielding form of the lander, rooted in place, exuded a frustration from the depths of the scientists' hearts. The cosmos had painted a mesmerizing picture, but it lay just beyond their reach. If only we could send something like a roving vehicle, a machine that could dance across the Martian surface, peeking beneath rocks, delving into the craters, and sharing its findings with us in real time, envisioned Eli, a passionate engineer on the team. NASA heeded these visionaries. They began developing prototypes for nimble rovers, dexterous enough to traverse rugged terrains with ease and grace. Imagine sending a machine that could whirl and swerve, powered by the longing for knowledge, snapping images of mysterious outcrops, sampling soil akin to a scientist in a lab. Each day would behold a new landscape, every pass would yield fresh discoveries, complex, winding traverses across valleys filled with secrets. Ultimately, science beckoned not only for answers but also for adventure, igniting the spirits of a generation entranced by the possibilities of the red planet. Perhaps Mars, with its sinuous channels of Christ waiting just beyond the horizon, would teach us to embrace uncertainty, to become the explorers we once dreamt of being. The challenge wasn't just to gather data and extract samples, it was to embrace the thrill of venturing into the unknown, to truly experience the wonders of Mars. As visions of rovers leaping across the Martian landscape lingered in their minds, scientists and engineers united, ready to embark on a path less traveled. And while they pondered the clays that cradled the potential for life, they continued to dream, of features not seen, of tales not yet spun, and of the lasting connection that would forever link Earth to the enigmatic allure of Mars, the Red Planet. Title: Echoes of a Red Planet. In the silent expanse of our solar system, Mars has long beckoned to dreamers and scientists alike, a tantalizing realm cloaked in a red hue reminiscent of rust. From the first tentative probes, like the Viking lander, groundbreaking discoveries have underscored this planet's potential, fluctuating winds carrying ancient clays across its barren surface, hinting at a time when water flowed freely, and perhaps, life thrived. As I gaze up at the stars, I can't help but ponder the intimate connection we share with Mars. After all, are we not composed of the very elements that once mingled in its craggy wilderness? By casting a wide net of exploration across its varied topography, we stand on the precipice of a monumental mission, one that promises not only to quench our scientific thirst but also to plunge us into new realms of human experience. Imagine navigating the expansive river valleys, climbing the colossal faces of ancient volcanic mountains, and traversing the enigmatic icy terraces of the poles. With every transmission sending back new vistas to our homes, we would collectively hold our breath, eagerly following the path of a rover controlled by our commands from millions of kilometers away. Its steady advance would unveil the secrets of a world that, despite its desolation, whispers of geological wonders waiting to be unveiled. And Mars is not a mere backdrop, it is a canvas that stretches vast and rich beneath our imaginations. The Great Pyramids of Mars, majestic structures reaching heights of 1 kilometer and expanding 3 kilometers at their bases, would stand testimony to the planet's ancient legacy. Erosion has blurred their features, but rather than reducing them to mere hills, these formations invite deeper scrutiny, perhaps they house stories of the planet's past worth telling. Yet, as we gaze upon Mars, we must confront the reality that, despite its alluring possibilities, the exploration of this world will not transpire swiftly. The surface area of Mars equals that of Earth, signaling centuries of potential discoveries that lie ahead. It is seductive to daydream about a time when we have intimately charted its terrain, after mechanized rovers have painstakingly surveyed its secrets, and human footprints have marred its pristine sands. But what shall come after that? Once every inch of Mars has been scrutinized, what will humanity do with this tantalizing orb? This inquiry triggers a chill. Witnessing our Earth's long history of environmental exploitation, we must tread softly upon the Martian surface. Should we discover life, no matter how small, even if it takes the form of microbes, would we dare impose upon this alien biosphere? Such life would belong intimately to Mars. An independent Martian biology would be a treasure beyond measure, demanding our utmost stewardship and reverence. In a hypothetical scenario where Mars remained devoid of life, its potential as a resource for Earth appears dubious. The prospect of ferrying materials between planets carries a steep price, one that would not yield returns for centuries. Yet the enchanting thought emerges, could we carve out a semblance of existence there? Is it feasible to terraform this splendid but inhospitable world? Gazing at the rusted landscape, one cannot ignore its shortcomings. A brooding sky devoid of breathable oxygen, the absence of liquid water, and an unforgiving bombardment of ultraviolet radiation render Mars less than hospitable. Climate, though a hurdle, may not be insurmountable. Antarctica's scientific stations stand testament to resilience against time and temperature. Through ingenuity, we could envision generating a thicker atmosphere, enhancing it with oxygen to permit a more Earth-like breath. Might we create a shield of ozone, protecting it from the unrelenting cosmic rays? Geological evidence hints that Mars once cradled a denser atmosphere. The remnants of this atmosphere persist somewhere within its soil, encased within rocks and layers of subsurface ice. Perhaps the mighty polar ice caps harbor them still. To unveil this hidden bounty lies a challenge. How can we transform the frozen caps into a welcoming cradle for life? Consider the prospect of dusting them with a dark powder, deftly designed to absorb sunlight, heating them gently to release trapped gases. However, transporting the sheer quantity required for such an endeavor is daunting, necessitating a fleet of rockets. Winds might scatter our efforts like dried leaves, witnesses to the radioactive minerals that quietly whispered the secrets of time. Deep within the vastness of our own solar system, two moons, Ganymede and Callisto, retold stories of warmth and wonder. Trapped under layers of ice, their secrets awaited discovery. Diligently scientists anticipated that radioactive decay within these celestial shells generated heat, and over billions of years, this heat transformed their icy interiors into swaths of slush and water, hinting at extraordinary environments, vastly different from one another. This was a concept one could muse on, only if we were granted a closer look. When the day finally arrived, just after dawn on July 9, 1979, the universe glimpsed back at humanity. Voyager 2, the ever-determined messenger, delivered the first sights of a world named Europa, who wore the name of an ancient legend reimagined in ice and mystery. As the cosmic clock struck 8:04 Pacific Standard Time, the images layered on the sleek glossy paper began to unfurl the secrets of this celestial body. How does an image from the edges of the solar system make its way to us, one might ask. The answer lay intricately entwined in the delicate ballet of technology and the cosmos. Sunlight cascaded upon Europa, its glow reflected back into the void where it encountered Voyager's sophisticated cameras. The phosphors danced with light, capturing the essence of this distant land. Once its image had been formed into iridescent pixels, it was transmitted back, journeying across 500 million kilometers through the silence of space. As the signal passed through the expansive ether, it found its way to Earth through the ear of a radio telescope, nestled in Australia's embrace, aimed steadfastly at Jupiter and its retinue of moons. The data danced like whispers through satellite communications back to Southern California. Here, at the Jet Propulsion Laboratory, computers worked tirelessly, transmuting raw data into images, much like an artist painting a masterpiece. The intricate design of these images resembled a complex newspaper wire photo, comprised of meticulously arranged dots, each a different shade of gray, tiny specks now invisible from afar, but together they conveyed something magnificent. After processing, the visual information was carefully preserved on magnetic discs, echoing the way sound was once captured on phonographs. The result was staggering and historical. Europa's visage appeared, smooth and mesmerizing, the first representation captured by humankind, revealing intersections of straight and curved lines that immediately beckoned the mind to wonder, what lies beneath? Are they raised ridges, or perhaps sunken troughs in a land transformed? With observant eyes, scientists pondered their origins. Was Europa becoming part of a grand cosmic tectonic system? How did these geological narratives relate to the stories told by Earth's own surface? What can we learn from the Jovian moons as interconnected pieces within our solar puzzle? Even as the technology of Voyager unfurled these visual treasures, it was left to humanity's greatest device, the brain, to unlock the enigma. While Europa bore its secrets near its icy surface, it kept its depths intact, shrouded in mystery akin to a billiard ball, smooth and unyielding against the backdrop of the universe's embrace. As the cosmos whispered its tales from the vibrant lives of distant moons, we were led deeper into an understanding of our place in the vast expanse. The dance of discovery continues, urging us to explore the myriad worlds beyond, shaped by time, filled with wonder, and just waiting to be unveiled. The narrative of our universe becomes increasingly rich, each line added is a testament to the insatiable curiosity that pushes us toward the stars. The journey was never merely mechanical, it was an odyssey of thought, imagination, and intellect that, even if we look peculiar in our quest, allows us to reach beyond the confines of Earth and seek the wonders of the cosmos. Traveler's Tales, a new dawn in cosmic exploration. The silence of space is an infinite canvas, unmarred by the chaos of Earth, yet in its vastness lie stories waiting to unfold. The daring spirit of exploration overwhelmed the crew as the ship's engines rumbled, awakening each traveler's anticipation. This ship, like a powerful harbinger of dreams, felt more than metal and circuitry, it is a wandering soul, destined to reveal the secrets of the cosmos. Day 1. As our vessel broke free from the gravitational pull of Cape Canaveral, a collective sigh of relief filled the cabin. The concerns about provisions, food, water, and life support systems, clung heavily to us like a thick fog, but we were now steadfast voyagers on an uncharted adventure to distant planets and shimmering stars. The instruments flickered with life, a reassurance we desperately craved despite the moments of uncertainty. Day 2. A slight twinge of alarm shot through the crew as the boom responsible for our science scanning platform failed to deploy correctly. Minutes felt like hours as engineers and scientists collaborated with cool heads, racing against time to salvage our mission. A failure could mean losing essential data that would tell tales of our solar system's history, and that is something we could not allow. Hope hung by a thread, but determination illuminated our spirits. Day 13. With hearts pounding in unison, we turned our cameras back towards our beautiful home, Earth. The first photograph captured the ethereal beauty of Earth and Moon, a delicate dance of blue and gray suspended in the infinite void. It was an image transcending time, reminding us of our origins as we ventured farther from what we knew and loved. Day 150. The engines ignited once more, propelling us forward on a meticulously charted course through the ink-black cosmos. Our trajectory correction was successful, a reassurance of the intricate balance needed in this celestial ballet. Day 170. Time passed uneventfully, there were no asteroid showers or bursts of starlight to lure us into a reverie. Routine checks ingrained in our minds like sacred rituals drove us forward, keeping the ship and crew ready for whatever lay ahead. Day 185. Exultation washed over us as we calibrated our images of Jupiter, the massive gas giant, marking a new milestone in our journey. The thrill of knowing we were about to glimpse the beauty hidden in the swirling storms of its atmosphere ignited our imaginations. Day 207. An echo of tension gripped us when our main radio transmitter failed. A backup was deployed, but the looming question lingered: what if it, too, would succumb to the relentless silence of space? How would we communicate our findings back to our terrestrial companions? Losing contact felt like severing the tether between home and the infinite. Day 215. We crossed into the orbit of Mars, our neighboring planet, now a mere whisper on the other side of the Sun, awaiting our next move, enticing us with untold promises of exploration. Day 295. With our entry into the asteroid belt, our senses heightened, the uncharted boulders tumbled around us, each a testament to time and an ancient cosmos. Like sailors navigating treacherous waters, watchful eyes remained vigilant, facilitating our passage through this celestial minefield. Day 475. Emerging unscathed from the asteroid belt felt like a rebirth. In our journey, we had harnessed the chaos of space into a narrative of survival and resilience, a testament to our ingenuity and spirit. Day 570. Jupiter shone in the distant sky, a jewel more magnificent than any telescope could ever capture. As we drew closer, the dynamic play of colors and clouds mesmerized us, a swirling cosmos of gas and light neither lands nor seas. Day 615. The enormity of Jupiter filled our viewports, changing, pulsating, hypnotizing us with its dynamic weather systems. With no mountains or rivers to anchor it, the planet presented a boundless ocean of swirling gases and floating clouds, a breathtaking glimpse into a world devoid of a solid surface. Day 630. Days morphed as we found ourselves adrift in Jupiter's magnificent weather patterns. The planet's rapid rotation flung atmospheric motions like an artist flinging paint on canvas. The playful winds and swirling layers of color sang the song of a world alive, incandescent with energy and motion. Day 640. Clouds flowed and twisted in patterns that stirred our souls, reminiscent of Van Gogh's brush strokes, raw and passionate. No artist could capture this kaleidoscope, for no mortal had ever ventured beyond Earth to perceive this realm of celestial surrealism. Beneath the vivid bands of white ammonia clouds and the brownish belts of hot sinking atmosphere, lay a plethora of mysteries. The blue holes punctured our gaze like windows into the depths of the Jovian sky, enticing our curiosity to explore further. Day 647. The Great Red Spot emerged, an ominous indicator of storms raging for millennia. Its towering gas columns soared high above the stratified clouds, hinting at the cosmic dance of matter, strong enough to cradle our home, Earth, within its turbulent embrace. Day 650. In this grand encounter, we swiftly understood the lessons imprinted on Jupiter, a story echoing through the fabric of the universe. The rocky remnants of ancient celestial bodies show traces of radioactive minerals, each a testament to history, to the processes that shaped worlds. Each log entry captured the spirit of human curiosity, echoing the profound truth that the canvases we paint in our minds extend far beyond the sights of the stars. Here, adrift in the harmonious expanse of space, we glean fragments of life's meaning on distant worlds as we boldly embrace the mysteries that await discovery. Each adventure enhances our interconnected tapestry, revealing our role in a larger cosmic symphony. Chapter 6, Traveler's Tales. In the vastness of our universe, a saga unfolds with every twist and turn of our spacecraft's journey through the celestial waters of the solar system. As we venture into the depths of space, we encounter wonders that ignite the imagination and challenge our understanding of planetary phenomena. Day 1, a day that will linger in memory, we set our sights on Jupiter, the behemoth of our solar system. A formidable task lay before us, as our ship must traverse its treacherous radiation belts, infamous for their intensity in chaos. The deck hummed with anticipation, despite the grim statistics that suggested damage was imminent. Our instruments, particularly the photopolarimeter, showed signs of wear. Yet as the ship sailed through the shimmering electric veil, we emerged victorious with only one minor casualty. The void of space welcomed us with open arms as we crossed the ring plane without a single collision, evading the particles and boulders of Jupiter's newly discovered rings. As we continued on our quest, the universe unfurled before our eyes as we captured stunning images of the Galilean moons. Amalthea presented itself as a tiny, reddish-oblong world, nestled at the heart of the radiation belt. Io, painted in vibrant hues, danced with the chaotic beauty of life. Europa, with its linear markings reminiscent of a cosmic canvas, offered glimpses into its potential secrets. Ganymede showcased delicate, cobweb-like features against a backdrop of grandeur, while Callisto, with its multi-ringed basin, imbued a sense of ancient history. We sailed past the orbit of Jupiter 13, welcomed gently towards our new destination, the infinite embrace of space beyond. Day 662 marked our liberation from the Jovian radiation belts. Sensors confirmed that the relentless pull of Jupiter had blessed us with an increased velocity. We soared forth like a bird finally liberated from its cage, gliding across the cosmic ocean, unburdened by the trials we had faced. Day 874 brought unexpected turmoil when we lost the ship's lock on the star Canopus, the celestial compass that guided navigators on Earth. It was essential for our orientation in the pitch-black surroundings of deep space, an unseen hand guiding us through uncharted territories. Panic fizzled for a moment as optical sensors confused Alpha and Beta Centauri for Canopus amidst their radiant glow. But soon, calm returned. Canopus was reacquired, reminding us that even in confusion, clarity awaited. 2 years hence, we set a course for the Saturn system, one of the most intriguing destinations yet to grace our journey. Among all the tales whispered by the stars, the vivid stories of Io captured my heart. Reach? The uncertainty was a presence all its own, heavy upon my spirit. In contemplating the night sky, I recalled the beliefs of ancient hunter-gatherer tribes, following the tendrils of thought they might have whispered under a blanket of stars. Could it be that few within those close-knit groups ever wrestled with ideas as profound and fearful as mine? Certainly, some may have pondered their place amidst the constellations, yet I suspected that never would they have grappled with all these thoughts simultaneously. However, such cultures birthed incredibly sophisticated ideas, their insights reverberated through pastoral songs, storytelling, and beliefs. One richly woven narrative came from the Kung Bushmen of the Kalahari Desert, who gazed up and saw the Milky Way tracing a luminous path overhead. They named it the backbone of night, their vision attributing to the cosmos a nurturing quality. In their hearts, the Milky Way was not merely a glittering phenomenon, it was a celestial construct that sustained the very essence of darkness, preventing fragments from crashing down and overwhelming the Earth. This elegant idea became a pillar of understanding, a metaphorical spine for their existence on a planet split between light and dark. As humanity learned to articulate their experiences, metaphors like the Kung's backbone began to shift. Cultures transformed their celestial wonders into a mythology populated by powerful deities. Names were given to these entities, each endowed with dominion over realms both profound and mundane. Every aspect of life became entangled in this web of divine influence. The gods ruled over the forces of nature, and their whims dictated the fortunes of humanity. With each change from season to season, there lay the fear that the spirits might grow displeased, leading to droughts, floods, and calamity unbound. Thus arose an entire industry of priests and oracles, charged with the task of ensuring these capricious gods were kept content, ever wary of their godly tempests. Across towns and cities, little remained of the majestic structures like the Hiraean on the Isle of Samos, an impressive temple to Hera, once a beloved goddess of the sky who cared for both mortals and the celestial bodies above them. Nestled among islands kissed by azure waves, echoes of her stories whispered through the winds. In a greater understanding of reality, an understanding that honors the legacy of those ancient thinkers who first dared to dream of a cosmos begging to be explored. The celestial dance continues, and within its rhythm lies the essence of the human spirit, a testament to inquiry, courage, and the haunting beauty of the night. Once, in the golden age of ancient Greece, where philosophy and science danced in delicate harmony, minds like Pythagoras and Plato began to whisper an age-old truth: the cosmos, vast and enigmatic, was not beyond the reach of human understanding. Yet, this very insight disturbed some. How could one accept the notion that the sun could rival the immense size of the Peloponnesus, an idea that rattled the cage of conventional thought? For many in ancient Athens, it felt naturally more comforting to envision the heavens as a compact and localized expanse, neatly contained within their daily perceptions. Consider for a moment the simple act of observation, an intricate interplay of perspective that governs our understanding of space. If one were to extend a finger, they might notice how it seemingly dances against a distant backdrop when viewed first with the left eye, then the right. This curious phenomenon of parallax reveals a profound truth: the closer an object is, the more pronounced its movement against that distant panorama. Inadequate spacing between one's eyes dampens the effect, translating into a less acute sense of distance. Expand the baseline, such as standing on opposite ends of a lengthy platform, and that perceptual shifting becomes even more vivid, empowering one to measure the great distances that lie beyond, yet often go unnoticed. But therein lies another twist: we balance upon a moving platform, our Earth, traveling a colossal journey of approximately 300 million kilometers from one side of its orbit to the other every 6 months. If we were to observe a celestial object, unchanging and everlasting, 6 months apart, surely we could extrapolate spectacular distances. Aristarchus of Samos dared to consider this in his theories, positing that the stars were not just tiny pinpricks of light, but indeed suns of their own, contemporaries placed amidst a cosmos that stretched far beyond familiar limits. Yet, Aristarchus's theories met with skepticism, for the absence of discernible stellar parallax hinted at an astonishing reality: if the stars were indeed suns, they must be hopelessly far away. Long before the contraption of the telescope changed our optical fate, the parallax of even our nearest star lay hidden, too minuscule to apprehend. It was not until the 1800s that the first parallax measurements came to light, illuminating with indisputable geometric clarity that stars were unfathomable light-years from us, rather than merely obscured neighbors. The Ionians, with their keen intellect, could have performed yet another inventive inquiry regarding the distances to stars, but they seemed not to embrace such notions. After all, a widely accepted principle governs our perceptions: as distance increases, an object's appearance wanes. This understanding, the inverse relationship between size and distance, underlies the very essence of perspective in both art and photography. How far must one journey from the sun for it to appear as diminutive and dim as the stars glimmering in the night sky? Likewise, how faintly luminescent could a portion of the sun become before it mirrored the shy brightness of a distant star? Bridging the eons, along came Christiaan Huygens, a man steeped in the Ionian tradition of inquiry and audacity. He meticulously crafted small perforations in a brass plate, held it aloft to the sun, and inquired as to which hole shone as brightly as Sirius, the luminous star that had captivated his thoughts the night before. Remarkably, the hole represented a mere January 28, 000th of the sun's apparent size. In a moment of inspiring deduction, Huygens proclaimed that Sirius must lay 28,000 times farther from us than the sun, approximately half a light-year. His memory served him well. While the intricacies of stellar brightness may fade with time, the brightness of stars etched in memory remains vibrant. Had he known that Sirius outshone the sun, his calculations would have aligned closely with the truth: the star lies a breathtaking 8.8 light-years away. The imperfection of their data did not diminish the brilliance of Aristarchus or Huygens; rather, their clarity of method paved the way for future astronomers. They sowed the seeds of understanding, which, when nurtured by increasingly refined observations, yielded ever more precise knowledge about the universe. From the moment humans first gazed up into the night sky, long before the remarkable tools of modern astronomy, questions of identity emerged. What are the stars? The answer, encased within the ether, resonates with extraordinary clarity: the stars are mighty suns, brilliantly illuminating the vast tapestry of interstellar space, existing light-years beyond our fragile world. The legacy of Aristarchus transcends the mere realms of cosmic contemplation; it beckons with a profound revelation. Neither we, nor our planet, occupies a place of privilege within the grand design of nature. This insight has since reverberated across disciplines, extending beyond the celestial into the spheres of anthropology, biology, politics, and economics. To this constant, it is the very rhythm of our existence. Imagine, though, a vast interstellar spacecraft, gliding through the void, leaving behind all that we know and love, untethered from the past. In that scenario, historical events would become mere echoes, familiar to the traveler but foreign to those left behind, unaware of the new trajectories that history might take in absence of their reality. Within that spacecraft, a delicate process unfolds. A sperm competes to fertilize an egg, an event that will usher in the next generation of humankind. Yet, the outcome of such a seemingly simple act is dictated by an intricate tapestry of factors, both subtle and overt, from the alignment of stars millennia ago to the mere chance of a breeze stirring at just the right moment. Reflecting upon this, one might ponder, if a single moment had shifted 2.5 millennia ago, countless lives would have unfurled differently. We would not exist as we are, different lives would thrive in our stead, a billion alternate paths woven through the fabric of time. What if the Ionian spirit, the vibrant thirst for knowledge and exploration, had triumphed over the distractions of war and dogma? Surely, we would be achieving wonders today that seem beyond our reach. We would have sent our pioneering vessels to explore the twinkling mysteries of Alpha Centauri, Barnard's Star, Sirius, and Tau Ceti. Our ingenuity might have birthed immense fleets of interstellar craft, silent behemoths rising from Earth's orbit, each adorned with symbols of our scientific heritage. In an imaginative view, one could envision the inscriptions on the vessels, written in the elegant curvature of ancient Greek, speaking of exploration and conquest, perhaps with one ship proudly boasting the name, Starship Theodorus of planet Earth, named in homage to our ancestors who dared to dream. As we navigate the present timeline, our quest for the stars is progressing, albeit at a tempered pace. Perhaps in a century or two, we will have fully explored our solar system, and with that knowledge, we will manage to put our home in order. Human ingenuity, paired with boundless resources and the accumulated wisdom of the ages, shall embolden us to venture forth. With our telescopes, we will peer into the infinite night, discerning the multitude of planetary systems that swirl around distant suns, some akin to our beloved Earth, others alien in every possible sense. The annals of time and space will note us as the descendants of Thales, Aristarchus, Leonardo, and Einstein, the titans who laid the foundations for our eventual journey. Currently, we find ourselves amidst a vibrant cosmos, surrounded not by one, but by a remarkable 4 planetary systems in our immediate neighborhood, Jupiter, Saturn, Uranus, and Neptune. Each of these grand celestial entities is accompanied by myriad moons, dispersed in captivating patterns that echo the very solar dance we have long known. Advances in observational astronomy suggest that nearly every single star, much like our Sun, may have its own suite of planets, waltzing silently in their orbits. Though our observational capabilities have yet to reveal the silent planets orbiting distant stars, mere pinpricks of light, outshined by the brilliance of their suns, scientific discovery has nudged us toward grasping the existence of these elusive worlds. Consider a distant star, exhibiting notable proper motion, gradually moving against the backdrop of the cosmos over decades. If it harbors a massive planet, one akin to Jupiter, whose orbital plane aligns fortuitously with our line of sight, an intriguing dance occurs. As the dark planet shifts, it subtly tugs at the star, altering its seemingly fixed path into a wavy journey across the celestial canvas. Barnard's Star, the closest of them all, becomes a prime candidate for uncovering these gravitational shadows. Yet, the search is no simple feat, it is an ambitious and meticulous pursuit, demanding decades of dedication as astronomers sift through photos, noting the minutest shifts in position. Preliminary quests have suggested the presence of 2 or possibly more Jovian-like planets in orbit around Barnard's Star, their trajectories calculated to sit closer to their parent star than Jupiter and Saturn are to ours. Alas, the observations remain inconclusive. 2 separate studies yield conflicting accounts, leaving the true nature of any planetary system surrounding Barnard's Star shrouded in uncertainty. In this intricate tie between history, science, and the infinite possibilities of existence, we reflect on our journey as humanity, one that began with the near imperceptible act of fertilizing an egg, now extending toward the cosmic horizon. We are not merely products of our past, but architects of our future, each choice a thread that weaves a new destiny. And perhaps, as we cast our gaze upon the stars, we are reminded that the universe holds secrets yet to be uncovered, and that every step we take brings us closer to understanding not just the cosmos, but the essence of our very being. Chapter 8, Travels in Space and Time. In the vast narrative of the universe, many historical events unfold, shaping realities that those left behind in our linear timeline will never realize. As the cosmic clock ticks, life itself grapples with the timeless dance of birth and demise, of creation and observation. It is within these fragile threads of existence that theories about the cosmos come to life, including the beginnings of our very own humanity, fertilizing an egg, and nurturing the next generation through its journey in the fabric of time. Yet, as we delve into the cosmos, we find ourselves in pursuit of clarity amidst nebulous findings, where unambiguous demonstrations await further scrutiny. Our quest for knowledge drives scientists to develop innovative methods of detecting planets orbiting distant stars. Among their strategies is the ingenious act of artificial occultation, where the blinding light of a star is momentarily obscured. In this diminishing light, hidden planets can emerge, revealing their secrets. By placing a disk in front of a space telescope or leveraging the cosmic shadow of our moon, researchers peel back the layers of brightness that otherwise obscured this celestial ballet. The coming decades promise to unveil the mysteries around us, with definitive answers regarding which of our nearest stellar neighbors boast the companionship of heavenly bodies. Recent explorations often gravitate toward the infrared spectrum, a realm that unveils the presence of preplanetary disks swirling with gas and dust. These clouds, amorphous yet structured, are believed to be the birthplaces of stars and their retinue of planets. Cutting-edge computer models simulate the evolution of these intricate disks, assessing how small clumps of matter collide and coalesce within these vast crucibles. As these cosmic experiments unfold, lumps of matter, like seeds in a fertile field, are scattered by chance throughout the disks. Over time, they attract dust particles, all while gravitational forces pull in the prevalent hydrogen gas within the cloud. Observing through the eyes of computer algorithms, we witness collisions where these clumps stick together, harvesting dust and gas until the cosmic material begins to dwindle. The conditions are complex and varied. Depending on the initial state of the gas and dust within the disk, we can see planetary systems forming. Sometimes we glimpse configurations similar to our own, 10 planets in harmonious orbit, with terrestrial worlds taking their place close to the nurturing warmth of the star and the jovial gas giants farther out. In other scenarios, nothing fruitful arises. The remnants may linger as isolated asteroids or evolve into massive moons that flirt with the line between planetary identities. As we stand on the precipice of discovery, tantalizing possibilities emerge. It appears increasingly likely that a glorious variety of planetary systems exists throughout our galaxy, hidden in the folds of space, waiting to be uncovered. Every star, it seems, emanates from such primordial clouds, gestating in the celestial womb that harbors countless worlds, perhaps even 100 billion of them. However, we must approach these alien environments with tempered expectations. Each world is likely unlike Earth, with only a handful appearing amenable to human life, while many others may exude a sense of danger. The beauty of these distant realms can touch the soul. Imagine vibrant landscapes adorned with multiple suns casting kaleidoscopic lights, or moons that loom vast and enchanting in the twilight. Other planets may gaze upon swirling gaseous nebulae, witnessing the remnants of stars that once burned brightly but now exist only as echoes of their former glory. Among the myriad distant constellations, our own yellow sun may appear tenuously, perhaps requiring a telescope to decipher its significance amidst the cosmic stage it oversees. Interestingly, the interplay of space and time manifests in cycles that seem to echo our own existential experience. Just as humans traverse through decades, gathering memories and wisdom, stars too have their lifespans, stretching over millions of years, an unfathomable age compared to human existence. To a flickering mayfly, humans appear as colossal, seemingly immovable giants, showing little hint of activity in the grand scope of the universe. Conversely, from a star's perspective, human life is a fleeting spark, a transient occurrence on an unusual sphere composed of silicate and iron, a tiny flicker amidst the grand tapestry of existence. As we journey onward, pondering the vastness of our cosmos and our place within this extraordinary unfolding drama, we understand that while we may have only just begun to grasp the mechanics of birth and life in the universe, the knowledge gained deepens our connection to the celestial stories written in the stars. Each question posed echoes forward in time, uniting generations of thinkers, dreamers, and explorers in the collective pursuit of understanding what it means to exist in a universe rich with potential and bound by the threads of time. Chapter 8, Travels in Space and Time. In a sterile laboratory, nestled within the heart of a sprawling research facility, scientists stand at the precipice of a significant breakthrough, one that has the potential to alter the very fabric of human existence. They have successfully learned how to fertilize an egg, initiating a miraculous journey that will bring forth the next generation of human beings. The implications of this discovery are profound, yet critics contend that an unequivocal demonstration of its long-term effects still lies on the horizon, beckoning further inquiry and exploration. Beyond our atmospheric boundaries, the cosmos is laden with mysteries and untold events, swirling in the vast tapestry of existence. Each of those worlds, orbiting distant stars, is alive with occurrences that shape their destinies. They are theaters of evolution, just as our Earth is, a celestial gyre, full of intricate interactions waiting to unfold, each with its own story and potential. As we stand at this pivotal juncture in our history, our moment mirrors one that occurred 2,500 years ago in ancient Ionia, where scientists grappled with the burgeoning theories of their time while mystics offered mystifying interpretations of reality. Those early thinkers, who dared to question the universe and sought truths beyond the known, set humanity on a course from which there has been no turning back. Their struggle for understanding against the backdrop of mysticism has echoed through the annals of time, shaping thought patterns and influencing societal structures. Today, the crossroads we face is unprecedented and equally consequential. We stand not only to shape our own civilizations but to establish a legacy for generations to come. The actions we take today, whether through scientific pursuit, policy decision, or societal ethics, will ripple through the fabric of time, echoing down the centuries, defining not only what future generations inherit but also directing their paths among the stars. If we are to chart a course into the vast unknown, we must confront our responsibilities head-on. Each choice made in the name of progress will send reverberations through history akin to the Ionian philosophers' confrontations with the enigmatic. Will we choose to prioritize collaboration over rivalry, understanding over ignorance? Will we safeguard our planet and its resources, ensuring a habitable world for those who will come after us? The weight of this moment is staggering. We have an opportunity to cultivate a lineage of thinkers and innovators who may one day venture beyond our blue planet, spreading the seeds of humanity across the galaxies. Among the stars, what we leave behind may determine our legacy as a species, perhaps even establishing a cosmic community among civilizations as they grow and evolve alongside us. The question looms large: how do we navigate the intricacies of time and decision-making, ensuring that our actions propel us toward a brighter future? As we gaze at the cosmos, a canvas painted with eternal possibility, we must remember that the choices we make now will resonate throughout existence. We hold the quill that writes our destiny. What tale will we inscribe upon the pages of history, and what will it mean for the myriad lives that follow through the eons? The cosmos awaits our answer. Chapter 9. Section, The Lives of the Stars. Title, The Cosmic Tapestry. In the tranquil dawn of ancient Egypt, visions of creation unfolded beneath the gentle embrace of the rising sun. Ra, the sun god, opened his eyes, shedding warm, golden light across the vast expanse of the desert. With each glance, he separated the shrouded mysteries of night from the vibrant clarity of day. It was said that from his divine mouth flowed the gods who danced in the ether, while humanity emerged from the bright luminescence of his eyes. All sentient beings, rich in purpose and gesture, were born of him, the radiant child in the lotus, where his rays breathed life into every soul. In the echoes of time, great minds pondered the immensity of existence. Isaac Newton, his intellect a beacon of understanding, grasped the very fabric of the universe. God is capable of conjuring particles of matter in an infinite array of shapes and densities, he mused. He alters the laws of nature to craft worlds spread across the cosmic sea. With every spectrum of creation, Newton saw no contradiction, it was but an affirmation of divine artistry woven through the cosmos. Centuries later, a different voice would resonate with curiosity. Mark Twain, ever the observer, reclined under a vast canopy of speckled stars. We lay on our backs, he reminisced, gazing upward, debating whether the stars were carefully crafted or merely serendipitous remnants of chaos. Each twinkle above ignited the fire of inquiry, a young humanity grasping the sublime tapestry of existence. And while the night stretched on, a solitary figure found solace in darkness. Vincent van Gogh poured his very soul onto canvas, overwhelmed by an insatiable desire for the divine. I have a terrible need, shall I say the word? Of religion. Then I go out at night and paint the stars, phenomenon akin to a cosmic beacon. Statistically speaking, supernovae occur in any given galaxy roughly once in a century, meaning that over the average lifespan of a galaxy, about 10 billion years, upwards of 100 million stars perish in such magnificent explosions. Yet they comprise a mere fraction of stellar life, only about 1 in 1,000 stars undergoes this spectacular demise. Following the Crab supernova, 2 subsequent supernovae were noted in the Milky Way, specifically in the years 1572 and 1604, diligently documented by the astronomers Tycho Brahe and Johannes Kepler respectively. However, the telescope was invented, and the heavens were no longer silent. Disappointingly, no further supernovae have graced our galaxy's canvas since the invention of the telescope, leaving astronomers eager with anticipation for new celestial fireworks. With a reflective narrative, Kepler, in his 1606 treatise De Stella Nova, on the new star, mused whether supernovae were simply the chance arrangement of cosmic materials. He likened it humorously to the random ingredients of a salad coming together purely by coincidence. His wife, however, slyly retorted, emphasizing that while chance might create a salad, it would not match the craftsmanship of her own. In our modern age, thanks to advances in technology, astronomers frequently observe supernovae in galaxies far beyond our own. A landmark moment occurred on March 5, 1979, when an intense burst of hard X-rays and gamma rays was detected by an intricate network of interplanetary spacecraft, pinpointed to the supernova remnant N49 in the Large Magellanic Cloud. This cloud, named after the explorer Magellan, continues to contract and emit its own elemental atmosphere into the cosmos. In every spark of light from a supernova, history is intertwined. Each explosion sends a pulse through the cosmos, offering whispers of our origin and existence. As we peer into the vast expanses of space, each twinkling star is a reminder of our connection to the universe, a connection forged in the fiery birth and death. Different redshift measurements, despite their apparent physical association, an unsettling revelation that continue to ignite debate. As we embark on our journey into the depths of space, tethered by the revelations of Hubble and Humason, we realize that every observation calls for contemplation, every detail demands scrutiny. Thus, the universe remains a canvas of mysteries, with each layer of understanding prompting new questions that ripple through the fabric of cosmology, an endless pursuit of knowledge where the edges of forever extend even further into the twilight of the unknown. The gesture of infinity, unraveling the cosmos. As the sun dipped below the horizon, a figure clad in a thick, woolen coat stood before the vastness of an azure sky, now speckled with the first hints of stars. The cold wind whispered in his ears, reminding him of his twin passions, astrophysics and exploration. He could almost feel the universe beckoning him, challenging him to unlock its mysteries. Far away from the cold, bustling city streets, where the hum of civilization often dulled one's sense of wonder, Leighton had come to a remote observatory perched atop a hill. With a sense of purpose, he adjusted the telescope, his eyes fixated on the swirling spirals of the galaxy. Those shimmering nebulae weren't simply clusters of gas and dust, they were the very essence of creation, island universes adrift in the cosmic ocean. He remembered a pivotal moment in astronomical history, one that had once captivated him during his studies. Pioneering minds like Edwin Hubble and Vesto Melvin Slipher had provided groundbreaking evidence, concluding that the red shift of light from distant galaxies was not merely a curiosity of the universe. Rather, it was the key to understanding cosmic expansion, revealing that the universe was stretching away like a canvas slowly unrolling. Leighton found a particular thrill in these discoveries, relishing the idea that galaxies receded, giving voice to the concept of an ever-expanding cosmos. Yet, even in this exciting narrative, questions lingered. If galaxies with vastly different red shifts were linked by cosmic spaghetti, how could they exist at such disparate distances? Leighton recalled the debates that had emerged from these issues, particularly those surrounding the work of astronomer Halton Arp. Arp posited that red shifts might not signify distance at all, instead, they indicated something far more perplexing, a hypothesis suggesting that quasars, those radiant beacons twinkling across vast stretches of space, weren't as far away as traditionally believed. Leighton could almost glimpse the tension in the scientific community as skeptics rallied, dismissing Arp's ideas as coincidences surely arising by chance. As this discussion echoed in his mind, Leighton's curiosity grew deeper, propelling his thoughts in myriad directions. What if, he pondered, those distant quasars weren't just bright spots in the night sky aligning fortuitously with closer galaxies? What if they were being ejected, flung outward by their parent galaxies with energies and mechanics not yet fathomed? If Arp's claims were accurate, it would unsettle the foundations upon which cosmological theories rested. He could almost envision a new realm of exploration, a variance of theories waiting to be uncovered. The breathtaking evidence for the Big Bang also haunted Leighton's intellect. The whispers of silence, the cosmic background radiation, were unmistakable. Produced during the universe's very infancy, the faint echo of those primordial waves was all around. With the sensitive technology on board a U-2 aircraft, astronomers had captured data revealing that this background radiation, while largely symmetrical, bore the fingerprints of imperfections. Leighton's mind raced with possibilities. The Milky Way, a shining gem in the cosmos, was reportedly hurtling forward toward the Virgo cluster at a staggering speed of over 1,000,000 miles an hour. He imagined the enormity of that cluster, a vast assembly of galaxies, each teeming with their own secrets, a jewel box in the sky containing spirals, ellipticals, and irregular shapes unfolding in the darkness. But why? Leighton murmured abruptly. Why would the Milky Way be drawn toward this gravitational monolith? The idea of cosmic currents guiding his galaxy toward an unknown future stoked his imagination, suggesting an intricate tapestry of alliances woven across the universe. George Smoot and fellow scientists had wilderness of ideas, asserting that the Virgo cluster, stretching across billions of light-years, could potentially house uncountable galaxies yet to be charted. Their excitement reverberated through the scientific community. Leighton found passion in their vision, imagining a multitude of superclusters shrouded beyond detection, each one vital for understanding the universe's architecture. Here was the crux of it all: the observable universe, a mere fraction of the cosmos, held layers upon layers of cosmic stories waiting to unfold. A kaleidoscope of galaxies, black holes, and celestial phenomena spun together in complex dance, like a grand symphony fueled by the dynamics of imperceptible forces. As the stars began to twinkle brighter, Leighton took in a deep breath, embracing the mysteries that lay ahead. The universe, with all its uncharted territories and questions waiting to be answered, was alive. With fervor coursing through his veins, he realized that the journey of discovery was not just about understanding the cosmos, it was about revealing a mirror to the profound intricacies of existence itself. And under that vast expanse, having made his pledge to probe its depth, he felt a beautiful alignment of purpose, an epiphany that his own story was intertwined with the galaxies that twinkled above. Leighton would not rest until he unveiled the stories they held. Chapter 10, the edge of forever. In the grand theater of the cosmos, the celestial bodies did not merely exist, they danced with an elegance both chaotic and structured. This ballet of the universe echoed the profound discoveries of scientists like Edwin Hubble, who provided the definitive proof that the spiral nebulae were, in fact, island universes, vast, independent galaxies shimmering in the void. What lay between these sparkling islands? Dust, stars, and the gravitational non-uniformity that collectively gathered the mass perceived in the Virgo supercluster and beyond. This emerging picture was a revolution in understanding, leading physicist George Smoot to reflect upon the chaotic birth of the universe. Observations suggested the Big Bang was less uniform than previously imagined, casting light upon a universe that was, paradoxically, very lumpy. This wasn't the gentle spread of cosmic dough but rather a tapestry woven with dense clumps and sprawling voids. A certain amount of lumpiness made sense, it explained how galaxies could coalesce. Yet, the scale of this non-uniformity was astounding, igniting the imagination to conjure a daring possibility. What if multiple Big Bangs occurred nearly simultaneously, composing a cosmic symphony rather than a solitary note? If we accept the narrative of an expanding universe, birthed from a cataclysmic Big Bang, we stumble upon deeper mysteries that stretch beyond our understanding. What were the conditions like in those first harrowing moments? What preceded that thunderous event? Was there an infinitesimal universe, barren of all matter, only to witness existence erupt from the void, raw and unfathomable? For many cultures, the answer rested in the hands of deities, a divine creator sculpting the cosmos from nothingness. But herein lies the quandary: if we ask, where does God come from, we find ourselves at an impasse. Declaring the origin of the cosmos as unsolvable may seem easier. However, if we claim a God who has eternally existed, isn't it equally plausible to suggest the universe has always existed, a constant cycle of creation and destruction? Across the tapestry of humanity, myths swirl like galaxies in the sky, each narrating a tale of creation, and the world before it. Such stories, rich in imagination, often portray the universe emerging from primordial chaos, reflecting a keen understanding of human existence. In the Pacific Basin, different cultures weave their stories with creativity and foresight. From Central Australia, the Aranda people tell of a beginning shrouded in perpetual darkness, where everything remained suspended in night, an impenetrable thicket that demanded light and life. In the Popol Vuh of the Quiche Maya, we find a realm of calm, silence, and stillness, an emptiness before the onset of creation, hinting at the potential yet to be realized. From the Gilbert Islands, a contemplative Na-Aryan drifts alone, unperturbed and unfulfilled, until a spark of consciousness births the desire to create, a reflection of the divine that lies within every being. The ancient Chinese myth of Pan-Ku speaks of a chaotic cosmic egg, from which the god emerged, swinging a hammer that shaped the world, signifying the power of creation emerging from chaos itself. Huainan Tzu, a voice from China's wisdom of antiquity, describes the amorphous state before heaven and earth formed, a time when clarity and substance fought for dominance, revealing the delicate balance of the universe striving to define itself. These narratives pay homage to human audacity, the courage to wonder about existence itself. The stories, while poetic, craft a stark contrast to our modern scientific perspective, one drenched in self-questioning and empirical inquiry. Unlike ancient myths, which were accepted as truths of a given culture, the scientific method dares to probe deeper into the fabric of reality, crafting theories built upon experimentation and observation, striving to decode the enigmas of life and the universe. As we immerse ourselves in the ongoing cycle of nature, where night follows day and seasons change, ancient minds pondered, how could such cycles occur if not by the will of gods? Was there a divine purpose guiding these vast rhythms? Could the cycles of human lives hint at the cosmic cycles that the gods themselves experience? Indeed, the quest to understand our origins, the cycles we are entwined with, and the very nature of existence is not merely an intellectual pursuit, it is a deeply human endeavor, beckoning us to explore the very edge of forever itself. Through the lens of science and mythology, we find reflections of our essence, a relentless curiosity that seeks to comprehend the unfathomable cosmos that surrounds us, with each star and dust particle whispering the tales of a universe that is both grand and intimate. In the unrivaled tapestry of existence, where dust dances with stars, an emboldened symphony unfolds. Within the depths of this infinite cosmos, every celestial body and ethereal element is intricately woven together by the gravitational forces that govern their interactions. This non-uniformity of gravity, a cosmic ballet, orchestrates the collection of masses that coalesce into galaxies, clusters, and superclusters, hinting at the grand mysteries that lie at the heart of the universe. Among the world's great faiths, it is ancient Hinduism that dares to embrace the profound idea that our cosmos is caught in a perpetual cycle of death and rebirth, a narrative woven with threads of spiritual wisdom and cosmic understanding. Presenting a striking resonance with modern scientific cosmology, Hindu philosophy reveals cycles of time that stretch far beyond our earthly clocks. The day of Brahma, a staggering 8.64 billion years, eclipses the age of both the Earth and the Sun, aligning astonishingly with epochs that echo through the annals of cosmic history, the reverberations of the Big Bang itself. In this vast theater of existence, there exists a mesmerizing image, the universe as a dream conjured by a divine being. This god, after enduring 100 Brahma years, sinks into a profound, dreamless sleep, pulling the very fabric of the universe into his slumber. Yet after the passage of another Brahma century, he awakens, rematerializing to dream once more the vast narratives of existence. As these cycles unfold, innumerable other universes burgeon, each cradled in the embrace of its own deity, weaving dreams as rich and varied as life itself. But gently does the notion arise that perhaps humans may not merely be the delicate dreams of the gods, inherited through genetic libraries and inscribed in the very essence of our beings, reflects our place in the universe and hints at the vastness of knowledge yet to be uncovered. In the grand tapestry of evolution, mammals embarked on a slow but transformative journey from the land to the ocean, a testament to the adaptive brilliance that shapes life on Earth. This narrative of gradual migration reflects not only the physical transition of species but also the underlying complexities of existence. Much like the incremental steps of these mammals, the convergence of genetic and neural information has taken eons to develop. 2 centuries ago, a typical distance bacterium was capable of processing roughly 1 million bits of information, an astonishing feat akin to digesting a library of 100 printed pages. This early snapshot of information processing, though quaint compared to today's standards, serves as a reminder of how far we have come. The evolution of complexity also led us to the pinnacle of cognitive sophistication, heralded by the functioning of the brain's cortex, the epicenter of our conscious lives and the seat of our humanity. Herein lies the true distinction of our species, the ability to generate civilization itself. Yet, the language of the brain differs from the poetic elegance of DNA, it instead speaks through the intricate symphony of neurons, microscopic electrochemical switches that comprise the very essence of our thoughts and experiences. Each human brain houses approximately 100 billion neurons, a staggering number that rivals the total stars of the Milky Way galaxy. Each neuron is a vital link in an elaborate network, forming around 100 trillion connections within the cerebral cortex alone. Charles Sherrington, in a remarkable vision, painted a picture of our awakening cerebral cortex, a sparkling field alive with rhythmic flashing points and trains of sparks, much like the celestial dance of galaxies. This vibrant orchestra of neuronal activity awakens the mind and prepares the body for the rich tapestry of life that lies ahead. As the dawn breaks, sub-patterns born from the larger harmony awaken deep within us, reaching into the unlit corridors of the lower brain, signaling that it is time to rise and embrace the world. Even during the twilight of night, the pulsating brain continues its intricate choreography, dreaming and remembering, engaged in the complexity of life. Every thought, every vision we experience holds a weighty reality, formed through hundreds of electrochemical impulses. Imagine shrinking down to the scale of neurons, where you might witness ephemeral patterns, each a spark of recollection, perhaps a memory of lilacs wafting through childhood summers or the nagging worry of misplaced keys, evoking the chaotic dance of human experience. Within the vast landscape of our minds, there exist valleys that mirror the mountain ranges of thought, intricate convolutions that augment the surface area of our cerebral cortex, allowing for the vast storage of information in a skull that often feels too confined. The brain engages in a ceaseless ballet of neurochemical activity, its circuitry more advanced than any machine civilization has created. Despite this marvel, the brain's operation remains rooted in the staggering connection of approximately 10 to the power of 14 neurons. Thought itself is segregated into two primary hemispheres, each a bastion of cognitive strength. The right hemisphere, a realm of intuition and creativity, fosters our sensitivity and ability to recognize patterns, while the left hemisphere anchors us in rationality and critical analysis. This duality embodies the essential opposites of the human experience, granting us the capacity to generate ideas while simultaneously evaluating their validity. A profound dialogue unfolds continuously across the corpus callosum, the bridge linking creativity and analysis. This interplay is fundamental to our understanding of the world and fuels our intellectual curiosity. When we quantify our knowledge as expressed in bits, it may be likened to the total number of connections among our neurons, around 100 trillion, or 10 to the power of 14 bits of information. If we were to transcribe this wealth of knowledge into the written word, it could fill an astounding 20 million volumes, rivaling the most extensive collections found in the world's largest libraries. This immense reservoir of knowledge, akin to the contents of 20 million books, resides within the confines of each of our minds. The complexity and capacity of our brains serve to remind us that, while they occupy small physical spaces, they host vast universes of thought and emotion. Here lies the legacy of our evolutionary journey, vast, intricate, and endlessly fascinating. Each connection, each thought, is both a reflection of our past and a stepping stone toward our future, where the interplay of intuition and analysis continues to shape what it means to be human, bridging the chasm between raw instinct and cultured intellect. The tapestry of memory and experience generates signals of such intensity that they traverse the vastness of space, detectable over unimaginable distances. To illustrate the potential, consider this. The Arecibo Observatory could theoretically communicate with an identical radio telescope positioned 15,000 light-years away, halfway to the center of the Milky Way galaxy, should we know precisely where to direct our signals. The technology of radio astronomy embodies a natural convenience. Under almost any planetary atmosphere, regardless of the chemical makeup, radio waves would find their passage, left mostly unhindered by the intervening gas clouds between stars. Much like how a San Francisco radio station's transmission echoes through to Los Angeles, radio messages navigate the cosmos with remarkable clarity. As we stand on this precipice of understanding and exploration, we find ourselves grappling with the intricacies of our universe and the potential presence of alien civilizations. Through the lens of science and mathematics, the tapestry of communication across galaxies weaves itself together, inviting us to decode the rich stories and messages that lie hidden among the stars, awaiting those brave enough to listen. Chapter 12, Encyclopedia Galactica. In the vast expanse of our universe, a delicate dance unfolds, a dance not only of celestial bodies moving gracefully through space but also of ideas, dreams, and hopes. Among humanity's most profound aspirations is the quest for contact with extraterrestrial life. Yet, as this pursuit burgeons, so too does the chaos of unbridled speculation. Amateur astronomers, driven by fervor rather than fact, often cast a cloud of confusion that frightens away the very professionals tasked with serious inquiries. This asymmetry between the curious and the cautious has led many capable minds to retreat into the shadows of skepticism, discouraged by a cacophony of voices projecting wild theories without foundation. The latter decades of the 20th century, the strategic forces of the United States and the Soviet Union bracketed the globe, directing over 15,000 warheads toward designated targets. No longer was there a safe haven on this planet. The energy held within those weapons, genies of death eternally waiting for the mere flick of a switch, knew no mercy. In mere moments, a blockbuster's wrath could deliver destruction, one fatal blow for every family on Earth, one World War II embedded into a lazy afternoon. Yet, the horrors do not end at the click of a trigger or the flash of light. No, the aftermath is just as grim, as the immediate causes of death include not only the cataclysmic blast but also firestorms sweeping through the streets, gamma rays ripping through flesh, and neutrons turning life into ash. A heart-wrenching testimony resonates through history, encapsulated by the words of a schoolgirl who survived the Hiroshima bombing, a moment that forever shifted the course of life on the planet. I remember the shadows burning into the walls, worse, to one small part of it, she recalled, a line that serves as a chilling reminder of our collective fragility. As the stars twinkle overhead, we stand on the precipice of decisions that could either elevate us to newfound heights or plunge us into unfathomable depths. So we must ask ourselves, what is the legacy we wish to leave behind? Perspective that reveals the interconnectedness of all things. Our explorations will become a communal endeavor, a reflection of our unity as inhabitants of this fragile planet, pushing forth not toward death but toward life, a magnificent extension of our understanding of the nuclear fire latent in matter. Earth, a fleeting but precious product of the galactic hydrogen industry, is a sanctuary for beings meant to be cherished, a stepping stone toward uncharted realms. Yet as we look to the stars, we must carry within us the sacred duty to seek out life, not as conquerors but as custodians of the universe, committed to fostering the very essence of being. Only then can we transform our aspirations from earthly concerns to the magnificent tapestry of life scattered across the cosmos, an existence marked not by fear but by a profound appreciation of the riches bestowed upon us by the universe itself. Who speaks for Earth? In the depths of the cosmos, where stars are birthed amidst swirling clouds of hydrogen, there lies a profound truth: within every atom resides the potential, the nuclear fire latent in matter. It is a fire that brought forth our home, Earth, a jewel among the barren void, sculpted by eons of cosmic forces. Earth is not merely a planet, it is a sanctuary, the latest masterpiece of the galactic hydrogen industry and a cradle for life, a precious gift to be cherished. As we look out into the abyss of space, we are driven by an insatiable curiosity. It is a yearning that compels us to contemplate not only our own origins but also the existence of life beyond our blue planet. The universe stretches out in all directions, beckoning us with the promise of discovery. Understanding the intricacies of Earth and its myriad forms of life is both a privilege and a responsibility that we must embrace, especially as we seek to answer the enduring question: are we alone? The realm of space exploration, be it unmanned robotic probes traversing the solar system or courageous humans venturing beyond Earth's atmosphere, demands a unique set of skills and dauntless commitment, qualities often mirrored in the realm of warfare. Indeed, the instruments of conflict carry with them a deceptive ease of application that can be reimagined to serve